I would like to give you kind of a background on, from a technical point of view, of like what makes resumability different. And so the kind of the key thing to understand is the way normally the system works is you server-side render, and once it gets the client, you have to do bootstrap. And this fat arrow over here represents the fact that huge amount of code has to be downloaded and executed before you can go on to the next step. So what is the goal of all this? The goal of all this stuff is to get an interactive website, right? You want to get interactivity. And well, how do you get interactivity? Well, you have to render the page, because rendering is a place where you attach listeners to the UI, right? So in order to get interactivity, you have to do rendering. But in order to do rendering, you have to have a state of the system. So you have to have a state of the system, but also you have to have all the templates present. And so in order to get here, you kind of have to work backwards and say, well, I need to render. In order to render, I need to have templates and data. In order to have that, I have to download everything. And so you end up just downloading this huge app right up front. And so the trick of resumability is that you start in the same place, you do SSR, and our bootstrap is super tiny. It has nothing to do with the application. Instead, it's just essentially a global listener, and it's super small. It's about 1 kilobyte on a modern device. It can take about 1 millisecond to execute, maybe 10 milliseconds on a mobile device that's super slow, but it's extremely cheap. And what this piece of code allows you to do is basically bypass everything and go straight into interactivity. And once you're interactive, when you interact with a page, you might have to download more code. So all of these arrows that you see over here represents areas where more code can show up. More code can come to the UI and make things interactive. And so instead of having one huge big fat arrow here, you have many small arrows all throughout the execution of the application. And these arrows not necessarily represent downloading of the code, although that can, but really what these arrows represent is the amount of code that has to be executed. It's about delaying the execution of all of the code up front. Yes, if you delay execution, you can also lazy load, but it's not about lazy loading the primary thing. Yes?
So just a point of clarification, loading is more loading into memory,
yes,
for execution's sake, rather than like shipping code across the wire. Is that correct?
Yes. So the expensive part is, well, all the bits are expensive, right? Shipping the code over the wire is expensive, but usually when we talk about expensive in terms of time, we're talking about the fact that the browser has to parse the code, execute the code, etc. And the problem usually you get into is that it's proportional to the size of your application. So if you choose an architecture where things are proportional, things might look okay during the prototype stage. But as the application gets larger and larger and larger, you're like death by 1,000 cuts, right? You're slowly decreasing the performance. And there isn't an easy place where you can just say, like, this is where things went bad, right? Like, it's like they slowly, over time, just got worse. Yes?
So the SPA approach, or the response to that is, oh, well, we'll break everything up into micro front ends.
Yes.
So then you have a limit. Let's say you have 1,000 apps. Each of those apps is only as large as that subset of routes or whatever.
Yeah, but building single micro front ends is not trivial with the current frameworks. They really weren't designed. It's possible. People have done it, but they're just an optimal way of doing it. And so one of the things I want to talk about is how Qwik is particularly designed in a way that makes micro front ends particularly easy to do with Qwik. And so before we kind of dive in here, I have this fun little 3-slide presentation that I think is fun to talk about. So I'm sure you're familiar with the CAP Theorem, right, in the databases. That basically says you can choose any of the 3 things. You can have consistency, availability, or partition tolerance, but you can't have all 3 at the same time. And then Google comes along and says, you know what, we're going to break this CAP theorem by installing atomic clocks in our data centers. And through the fact that we have a clock that we can guarantee is the same through all the atomic clock centers, we can actually build a system called all 3. It's called Spanner, and it is available. You can use it on Google Cloud Platform. And I think it's kind of amusing that there's a theorem that kind of was broken. Not really. So we're gonna, as a joke, but I think it kind of points it out, is that I think there is a front-end CAP theorem as well, which is that you have all these technologies, and all these technologies give you 3 things, but you can only have 2 out of the 3. And then basically there are capabilities in terms of like what you can build with a particular technology. You can have an awesome DX, and you can have a good startup performance. And it turns out you can have 2 out of the 3 right now. So for example, let's pick on React or Angular. Most frameworks we have today fall into that category. And so what you get is that you have awesome capabilities, right? There is very little you cannot build with React, Angular, Svelte, and so on. And people love the DX of these technologies. They may necessarily love all of them at once, but like, there are people who say like, yes, the developer experience is great. But we know that startup performance of all these hydration systems is really not that good. And so you can't have startup performance. So then comes along Astro and says, we have amazing startup performance, or 11T. And people love using Astro. They have also good developer experience. But guess what? You can't just build anything with 11T or Astro, right? All of a sudden, the kinds of applications you can build are greatly diminished. And so again, you're in the situation where you get to have 2 out of the 3 things. Google Wiz is the internal framework that I kind of mentioned yesterday for building fast performant applications. So Google Wiz, actually, you can build just about anything you want in terms of the capabilities. And it has amazing startup performance, as I talked about. It's powering Google search. But it's public. The Google Wiz is private, so you can't see. But I can tell you that building web applications with Google Wiz is cumbersome. It is not easy. There are many constraints in there in the system to make it fast. And so again, you're in the situation where you're only having 2 out of the 3 things. And so the thing that we're trying to do with Qwik is to put it actually in the middle, where you can build anything you want with Qwik. You do it in a developer experience that you enjoy, and you can have a startup performance that you want. You want to have all 3 in a single framework. And I think there's a new set of frameworks that are kind of coming into this category. One being Qwik, the other one I think is Marco, and so on. But I think this is the kind of the future of the things, is that we've been too long stuck in choose 2 out of the 3, and really you want to be in the world where you can have all 3 all at once. So let's go and let's build some stuff. I think the most interesting place to start is that let's take I'm going to choose React because this happens to be a place where I can easily get React up and running. And let's build a small app in the React. And let's say we want to get lazy loading or resumability in. And so let's see what kind of issues we're going to run into. OK, so here is a simple React application. I think this one is all in the client. There's no server-side rendering. But you can imagine that, let's say we have server-side rendering. The thing that's interesting here is that React needs to be able to run your application to figure out, are there any listeners anywhere? And so whether or not this application is actually interactive, this one isn't, right? Because there's nothing in here. React doesn't know that. And so it has to go and execute all of the code in order to figure out, like, where are the listeners? And sorry, I don't mean to pick on React. This is true of all frameworks, right? So we're going to talk about React because it's easy to get it up and running in this browser, but the same thing will be true of Angular, Svelte, Solid, whichever framework is your favorite. These things are going to be all true in those frameworks as well. So let's build a new counter. So let's say we want to have a counter, and let's see how good my React skills are. So let's see, we need to have a const. We're going to have a state, so count, set count, use state. Do I have to import? I have to import something. Import use state from React. OK, there you go. Return. Count is count. Button is +1 on click. Is set count count plus 1. Okay. What? Why is this possible? Oh, because I have to say initial value is 0. Okay. So now that we have a counter, we can say counter. Use state, refresh. Oh, it's just way down. Okay. Delete this. There we go. And now, there we go. Okay. Sanity has returned. Okay. So now it does counting as you would expect. So let's do another thing. So let's say we say, okay, we want to lazy load a particular thing. So let's say we want to lazy load the counter. So the way you would do that in React, right? I believe you download lazy and suspense. And now in here you say, whoops, you say const lazy counter. And then here you say it's a function that does import lazy counter dot like this. And then I think, do we have to do await here and then say default? Oops, await. Okay, so now that we have a file, yeah, did I mess something up?
Don't you have to export the counter so it can be imported?
Oh, so I'm going to move it here. So
gotcha.
I am going to create a new file called counter.tsx. And then we're going to move the counter here. Oh, nope, that didn't do it. So tsx, we're going to take this, counter tsx, export, and then
do you need a default keyword?
Yes, thank you. The export default function counter, and then we have to import use state from React. Okay, so that should be that, and then we go back to the TSX. Then we have our lazy counter. Cannot find errors corresponding declaration. Does it have to be .js? I think it has to be .js here, right?
It has to be relative to TSX.
Thank you. Is the JS required here? No. Do you know? No, it's not. Okay, so now we do suspense. And then in here, suspense. In here we can put lazy counter. Let's see if we Repl is out of sync. What? What?
Your closing tag is missing a character.
Lantang.
Yes. Is that going to work? Moment of truth? No. Why not?
It's not like in your import.
Oh, await. No, await.
Since the counter component is the default, you don't need to mark that the factory that you're passing into lazy. That can just be a function that returns import .whack counter.
Like this? I do have to have a await in here or no? Okay, so I can skip the async part. There we go. Ah, look at that. It's working now. There we go. And so I want to point out a couple of things. First of all, that was a lot of work, right? And there's many things we had to do. We have to come up with a name. We have to put an import. We had to have the suspense boundary. There's many things we had to do in order to kind of create this lazy loading thing. And this is, again, true not just in React, but in any existing framework. But the whole point of lazy loading this thing was to say like, hey, we don't actually need this thing, or we may or may not need this, right? But guess what? It doesn't make any difference, because when hydration is running, the problem is React has no idea, or the existing frameworks basically have no idea where the listeners are. And the only way to figure out where the listeners are is to start at the root and just visit every single thing. So the fact that we created a lazy loaded counter over here, we helped nothing. To kind of make a point here, the realization is that the only time the lazy loading actually helps is in the case when the suspense would be behind an if statement. And the if statement would be essentially false, right? And then it becomes true later on. And if you think about it, routing is just a very complicated if statement, right? So the point to make here is that lazy loading isn't actually helping you in a case of when the component is inside of the render tree. So that's kind of one problem, but let's keep going. So let's say now we say, okay, but you know what? The thing that we don't actually need is the on-click button. Can we make the on-click button lazy loadable, right? So we can say, no problem. We can take this piece of code here and move it to another file, increment.tsx. And we do, again, export default. I think just that, right? OK, so now we have problems. Now we're like, we don't know what set count is. Yeah, that's true. So that's because originally it was a closure, and now it's a function. So we need to do something. So we need to basically say we can pass in the set count, and we can pass in the count, those particular two things, right? And now it's not liking it because, OK, yeah, because it's any. So let's just cheat over here and ignore this for a second. This is a number. But this basically gives us the lazy loaded stuff. And so now we can go to counter and say, great, so what are we going to do here? Well, the thing to do here is to say import increment. And here we do have to do await. And can I just call it directly, or do I have to say that default? Async dot default, and then we pass in set count, comma, count. And let's see if it works. Yes, it's still working. OK. Again, I want to point out just how much work it was to make something lazy loaded. But notice what we didn't actually solve. We made the code over here lazy loaded, but now that it's lazy loaded, you have all these problems like, well, yeah, but like, what if you don't click on it until later? Or the first click is going to be slow because you're not prefetching it. So now I have to go and say like, great, this particular thing is lazy loaded, but now I have to go and somehow tell my boot up sequence to start prefetching these pieces of code so that it's going to be fast for the user. And again, the situation is that it's a lot of work. I have to figure out the name of the file. I have to figure out what to export it as. Now my application code is now spread across multiple things. But it's even worse because what if this button is something that's clicked often? Like, how do you make sure that this particular button is eagerly available or is put in the correct bundle? Because now the bundling system has no choice but to create a separate bundle, right? You have forced the bundler to have a separate bundle. Like, there's no way for the bundler to be like, yeah, I got you. You don't actually need this, right? And so, you know, when we talk about how Qwik has all this lazy loading and all these capabilities, it is easy for people to say like, actually, I can do the same thing in my favorite framework. And in a way, they're not wrong. You can, but you can see how very quickly you're going to just run into all kinds of problems. And the main problem that we did not solve here is the fact that the framework needs to know that there's a click listener. And in order to do that, we again have to go and execute everything. And once we come across this onClick listener, guess what? There is a state, count and set count, that needs to be passed into the closure. And so we now have left behind basically just yet another different kind of closure. We didn't get rid of this closure. We just moved the problem somewhere else. And so it turns out that if you want to get rid of this particular closure, it is not trivial at all. This is the hard bit that you cannot solve. And we're in this strange world where, when you end up with a large application, people will come to you and say like, well, that's easy, just do lazy loading. But then you actually try it and you realize it is not that easy at all. And even like, how do I know which of these listeners matter, which I have to pull out, which do not matter? How do I prefetch the code? How do I break it up? And I still haven't solved the problem that there is hydration, that there's this eager execution of all this code in order to figure out where the listeners are.
Would it, excuse me, would it be fair to say that frameworks like React, Angular have a de facto assumption that they have immediate or they have access to the full state of the application at any given time? And since they're architected that way, if you want to do anything different, you're going to have to explain every case where you want to break that pattern, because it's not so much the fragmentation that's the problem, it's the coordination. This is the microservice issue. Sure, individual microservices are faster, but now you rely on the internet to coordinate them.
That's right. That is an excellent way of looking at it. It's my observation as well, right? The bottom line is that all of our existing frameworks have been written with this idea that when they run, all of the code is already available for them, right? This is an assumption that's perfectly valid on a desktop application system. And I think many of our frameworks were inspired by similar frameworks on a desktop. I know when I was building AngularJS, I was heavily inspired by Flex. And Flex just was probably inspired by some desktop version of it as well. And so it just made an assumption that all the code is just available to you. I don't even think there was a possibility to do lazy loading of code in ActionScript. I don't even know if that was possible or not. But that just wasn't even a thing, right? And so all of the existing frameworks basically just make this assumption that when they run, all the code is available. And that's the fundamental assumption that we kind of want to break, right? We basically want to say like, no, that is not the case. And once these frameworks realize that, that all the code is not available, they try to introduce lazy loading into the system. But the thing that's difficult about lazy loading is there's two problems. One, it produces the problem of asynchronicity. So this onClick is a synchronous thing. And one of the things you're supposed to return out of the onClick is prevent default. Like, should the default be executed or not? And that has to be returned synchronously. But now, when I put async in here, if I wanted to go to here and return, return false, it's essentially going to be ignored because the place where it's over here is not available. So, even if you try to insert lazy loaded stuff, the problem is that the whole framework is designed with synchronous APIs. And there is no easy way to get asynchronicity into the system. And yes, there are workarounds, such as the Suspense. Where is the Suspense? It's in the app right here. There is Suspense, right? But if you think about how Suspense works, is the framework fully executes everything synchronously. And if it decides that it's missing that particular thing, it basically aborts, waits for the data to show up, and again starts from the root and tries to do the exact thing continuing, right? So it's not fully asynchronous. It's an illusion that there's this asynchronicity in the system. And again, this is not specific to React. All of the frameworks work this way, right? And so the fundamental difference is that we need a framework that understands the fact that data, or rather data in the sense of the code, right, may or may not be available for you synchronously. Then you may have to put a synchronous boundary anywhere you want. And so in Qwik, one of the main things is that asynchronicity is just built in. Like I can data bind to a promise and it just works because, well, it's just how everything about Qwik is asynchronous. So let's do something similar in Qwik. Let's build the same exact app in Qwik, and let me show you the kind of the differences that occur. Okay, so let's take over this Hello World app, right? So I'm just going to take over the Hello World app, and we're going to start implementing parts in it. Okay, so hello index. Okay, so here's our Hello World app, and I am going to delete the content over here. And let's say we want to put a counter in this location, right? Just like we did in the other system. Export, default, sorry, not default, counter. Count is so const count is use signal. So that's kind of a first difference, and let's talk about that in a second, why that is. And then we have a button on click, count value plus plus. Yep, that sounds all good. Let's just say +1 to make it the same. And
the import statement looks wrong.
We need an import statement. And why is this complaining? Oh, because I'm missing a parentheses. And
it's trying to import a counter from the wrong location.
That's what it is. Okay, so now we have a counter, and look at that. We have a counter over here that we did. So we basically wrote the same exact thing without thinking about lazy loading or anything like that. So what happened differently? So first of all, we have these $signs, right? And what the $signs tell the system is that this is a potential lazy loading boundary. A potential, right? Like we don't know whether this is a good idea or not, right? So the point of the framework isn't really to lazy load everything into pieces, but rather to introduce places where the lazy loading can happen. And one of the things we talked about is promises, by the way. So let's see if this is going to work. So if I do promise value, and let's just say 1, 2, 3, promise. Yeah, why are you not liking it?
Resolve. Or we.
Okay. So notice it prints promise over here, right? So the weird thing about Qwik is that everything could be asynchronous. And it has to be, right? Because if it isn't, then you can't introduce a lazy load boundary. And so this promise here, it's not that the Qwik was trying to render, then came across a promise, and then we need to give up and retry the rendering from the root. No, it's just like, oh, it's a promise. Let me just stop. And I can stop because everything needs to be asynchronous. It's just a fundamental property of this framework. And then when the promise resolves, the framework can continue, right? So if I instead of promise, let's do a delay. So let's see function delay. Let's see if we can get this implemented. What is it? Set? No.
Set timeout.
Return new promise, right? Is that right? Set timeout, resolve. Yeah, I think that's right. Oh, so we put that in delay number. Delay. And so here we have delay 1, 2, 3, and let's say 1,000 seconds. And so actually, yeah, so let's do that. And what is the reference? Right. So this is the lazy loading trick again. Okay, so let's actually go in detail over here before I just skip over this. So the problem is that it says the identifier declared at the root the delay, it needs to be exported in order to be used inside of QRL, right? So this thing here may or may not be imported. But because it may be imported, right, from a separate file, the code might be moved somewhere else. Because of that, it will no longer be able to access delay. So we have to make sure that this is exported. And then this should be happy. Yeah, because it's a promise of number. All right, perfect. So notice we wait. So here, let's print hello. Did you see what just happened? Like, isn't that crazy? Let me do this. Let me do this hello world. Okay, value, let's do t here. Okay. So hello. Because both of these promises kicked off at the same time. So let's do this one as 2000 world count, and then the rest of it shows up, right? And it's streaming, right? So as these things are resolved, it's streaming, and because it's streaming, you're not allowed to go back, right? You can't just be like, oh, I tried, but it didn't work, so let me retry it. Like, none of this is possible, and so this is the kind of the key property of the system. Yes?
Would you mind opening the network tab?
Yes.
I'd love to see what's going on under the hood there. Just, I think
network
it really
tab,
helps reinforce what's going on.
Font, all, and yeah, what would you like to see? What just happened? What did I click on?
Collapse, hit escape.
Yes, okay. So yeah, no, it just literally created HTML. Where's the HTML? Here. Oh, can I not search this? It's not a thing? Okay, hold on. So this is the error boundaries. They don't count. Where is, oh, right, because it needs to be formatted. Hold on, let me format it. And this is the error boundary. This is the head. This is the styling. This is main. Here we go. Right? Nothing in the output tells you that there were promises in there. It literally was just streaming, right? It came across a promise and said, well, I have to wait for the promise to resolve. And so it pauses, promise resolves, and says, okay, there's the next promise. I'm going to wait over here, and then continues streaming to the rest of it. Yes?
In the headers, is it like chunked or something like that you can see that it's streaming, like a streaming response? Transfer encoding chunked, I think, is how you can tell.
I mean, it's a network, right? Everything's always streaming in a network. Is there a chunked response header? Oh, yeah, it is. Transfer encoding chunked, right? I mean, if you think about it, it's just how networks work, right? Like, if I want to send you a large file, I don't send it to you in pieces. I'll synchronously send it bit by bit over to you. Yes?
I'm sorry, I'm confused about that response. Did we miss an earlier transfer?
No, this is the transfer, right? Like, it's just this. Sorry, what are you confused about?
So if you could just do a clear cache and refresh, just want to see the whole thing again. What I'm not understanding there. So what we initially see versus what it resolves to.
Right. So the server. Let me do a response. Let me look at it again. The server starts sending all this HTML, and it sends it all the way until it hits the hello, right? So it stops right here. It sends it all the way up to here, and at that point it says, just flush the data because I don't have anything more, and pause, and just waits. And finally the promise resolves, and the promise resolves to the world, right? So then it sends over the world's string, right? This is invalid HTML. It's unterminated, right? But the browser is like, yeah, that's what I see is up to this point, and that's what I've rendered, and I'm just going to assume that it's terminated in a normal way, right? And then the question mark and count and everything else shows up. So things are showing up in sequential order. It's just that there happens to be a 1 second delay between the colon character and a W character, and another 1 second delay between the D character and an exclamation point.
Gotcha. So then I guess if you were to resequence this where you have something loading later but earlier in the document,
right?
That would
So
no longer be.
If I put 1,000 here and 2,000 here,
Let's say, yeah.
well, the first one is going to block, and the rest of it shows up, right? And that's how it works today. One of the things we want to make sure it's possible is out-of-order streaming. This is not something we have implemented just yet, but it's relatively straightforward for us to implement. And basically what we would like to do is when we get to this location right here, let's find this. Actually, let's go to network. Where is that? Here we go. So in our case, the exclamation point result first, right? So what we could do is we just leave behind basically a marker, a div or something, right? Saying like something goes here, we don't just yet have it. Go and render everything else. So stream everything behind it. And then when the world resolves, we know the div and it has some kind of ID. And we can put in a tiny amount of script tag that basically says, query selector on this ID, dot inner HTML equals this thing. And then the whole thing works. Now, it gets a little more complicated because, well, what happens if the user starts interacting with the application before the promise resolves? So actually, when you do this trick, you have to send two things over. You have to send over the HTML, and you have to send over the actual resolved value. And so then, if you're in a situation that the user hasn't interacted yet, so the application hasn't been resumed, then inner HTML is a safe thing to do. But if the application has been resumed, then inner HTML is not a safe thing to do. Instead, just tell me what the value is and let the JavaScript on the client take over and do the right stuff. So both of these modes are pretty straightforward, and they are very consistent with how the Qwik just works out of the box. And so this is why we think that enabling out-of-order streaming would be a super cool property. We think it's pretty straightforward to do, and it will enable all kinds of interesting use cases. Let's break up the thing a little further. So one of the things we saw in the React application is that the system had to start at the root, walk all the components, and visit them. And as it was visiting them, it could figure out where the listeners are. Right? So if you look at the HTML that we have here, there's a couple of things. First of all, we have these comments. QV means Qwik virtual node. Historical reasons why it is. It's not really important. But basically, these text nodes tell the framework where the component boundaries are. So in order for any framework to work, it needs to know where the components are. If you don't know that information, frameworks can't do anything useful, right? And so Qwik is no different. Qwik also needs to know this. But instead of figuring this information out by executing all the components and kind of building up the graph that way, the graph is serialized into the HTML. So just by looking at the HTML, I know that there are 3 components in this particular location. I know there's a component here around body and so on. And so I can, if I find my component, this is my div right here, right? So my component started here and ended over here. So just to kind of prove a point, let's get rid of these. Let's say this has 2 roots. And let's say we can span hello world. OK, let's say we have these 2 roots, right? When we get over here, you see that this and these 2 divs are inside of this QV, right? This is the beginning component, this is the ending component, right? So this QV represents our component. Now, let me for a second just remove this button. So what's the easiest way? OK, let me just remove this button. So this is pretty straightforward, right? Right now, the application is completely not interactive. There's nothing I can do to make the application interactive. And because of that, if you look at the amount of code that was serialized, this is the serialization of the system right here. It says, there's nothing that needs to be serialized, like it's empty. And at the very, very top, it has this thing called a container. And we're going to talk about containers kind of more in depth later. But what it's saying is that this container is paused. It was also rendered by this particular version using the SSR. And this is the URL where all of the code can be downloaded from, right? So we tell it where the code lives. You can kind of see what version was used for rendering it, and basically just saying that this particular container is paused, meaning the resumability has not yet happened. What that means in practice is that this script tag, which contains the JSON state, hasn't been parsed, right? And so in this particular case, this script tag is, this JSON over here is essentially empty. There's nothing of interest in here. There's Vite, we ignore Vite, and this is for prefetching, so we can ignore this. This is for error handling. This is all dev mode error handling, so that it also doesn't count. right, so this is Vite, this is error handling for Vite, this is error handling for Vite, this is Vite itself, and so and then this is prefetching of the code. So in this particular case, the framework looked at it and said, there are no listeners, right? We didn't leave any listeners in the DOM. And because we didn't leave any listeners in the DOM, there is nothing that the user can do to interact with the system, right? And because there's nothing that the user has to do to interact with the system, there is no need to even send the quick loader across, right? Quick loader is the thing that sets up a global listener. So let's set up a listener. So now that we have a listener, we have this button. Things have changed over here, mainly that new script tag showed up. This script tag represents the quick loader. What the quick loader does is it sets up a global listener on the document. And in this case, it sets up a click listener, and it knows that because the system said, like, oh, there's a click listener in there. When I was doing rendering, I saw that the developer has placed a click listener somewhere, and therefore, quick loader has to set up a global click listener, right? So this piece of code right here tells the quick loader to set up a global click listener. And now any clicks on the page will bubble up and will be intercepted by quick loader. And then when the quick loader gets a click event, it basically says, is there an attribute? Looks at the path, right? The event has a path, and it says, is there an attribute in here that tells me what to do? And so it's looking for on:click because click is the event that happened. And so this button has this attribute which basically says where exactly should the piece of code be downloaded from, right? And so this is the file name, and this is the symbol that we need to download. Now, if you remember in our previous case where we were looking at, what happened to it? What happened? Did I minimize it? Okay. In our REPL, that seems like it's no longer here. Okay, this REPL. One of the problems we had is that we couldn't just lazy load this code. That code had closure, right? It wanted to know about set count, and it wanted to know about the value of 0. So you can't just lazy load this thing. Or to put it differently, the entry point to the system, right? In order to make the system run, I have to enter in the app so that the app can run all this code, which eventually gets to the counter so that the framework can create set count, and that set count can be passed in here. But that means that the initial entry point where the system starts executing is always here. This is always the initial entry point, or more specifically, the entry point is always this, right? This is the place where the application always has to start. All existing systems work this way. Like there is equivalent of a main method, right, where the execution has to start executing and everything goes from there. So the thing that's unique or different about Qwik is that the initial piece of code that we execute is not the main, but rather the click handler, right? And so we have a problem now. If you look at the click handler, you realize that the click handler needs to get a hold of the count. So do we have to execute the component use signal in order for us to get a count so that you can get over here? Right? That's kind of the tricky part that you have to solve. And so the way this is solved is that if you look at the JSON, this JSON originally was empty, but now this JSON has additional information. And the information that it has is basically that there is an object or there's a signal that contains 0 over here, right? And this object is really just one of these special objects, as you can see over here. This is just an escape sequence for a signal, and this is the value of the signal. And this particular object happens to be the first object inside of this array. And so if you go to this thing, there's a bracket 0 over here. What this means is that when this function executes, it needs to close over the signal. So the signal has to be brought back to life before this function can execute. But we did this manually in here, right? We basically said, when we had a counter, we manually passed it here. But in order to be able to pass it, we had to create it, which means we had to execute the component before we even set up the listener, et cetera, which completely defeated the purpose of lazy loading, right? So the hard part is to create a new entry point to the system, right? Existing applications have one entry point per application. And no matter how many lazy loading stuff you do, you're not changing the fact that the entry point is the main method. Whereas here, by creating a click listener, we have created an entry point into the system. And the execution can start at this place independently from everybody else. So if I implement another button that instead decrements, right? Now we have two buttons which have now two entry points in the system, right? The execution can start either at button A or it can start at button B. Those are two separate places where the execution can start from the system. And so what's happening is every time you have really a $sign in your application code, every time you see this, this is a potential place where the system can start executing. And this is the bit that existing frameworks don't know how to do. And because they don't know how to do it, resumability is not really possible with them. Yes?
Is there any benefit of essentially each of those buttons has its own functionality? It's, in this case, very obviously simple, but is there any benefit as you transition into more complex functionality to introducing yet another component $sign as a potential lazy?
Yeah, so you can
boundary?
absolutely do that, right? So we could say that this behavior here, so let's create a new function const add value, right? And then this one says, right? And then we could say count.value plus equals value, right? Oops. And so then in here, instead of adding plus plus, we can say add value 1, and here we say add value -1, right? And so this would work, right? This is not what you had in mind? It's red, and I'll explain why it's red. But
yeah, or even external to this component. I mean, I guess I'm understanding that component $sign is a potential boundary.
correct.
And I guess I'm wondering at what point, as you're introducing this nested functionality, at what point does it make sense to introduce another potential boundary?
I think that is dependent on what you're building. Like it's a decision that the developer has to make, right? Like the framework's job is to make sure that whatever you come up with, the right stuff happens on our side, right? You as a developer need to decide, like, is it worth refactoring to a common place or not, right? Now, what I wanted to point out over here is that you would be tempted to do something like this, but the problem is we would not know how to serialize this bit over here, right? And so again, this is giving this error saying like, hey, this thing you gave me, this add value, is not serializable. I don't know what to do with it, right? And so if you want to pass functions around, you have to wrap it in a $sign to basically tell the serializer, like, hey, do your magic here so that this becomes serializable. Oops. Right? So just by wrapping it in a $sign, you basically told the serializer, okay, make sure this is a function, and now this closure doesn't close over the use signal, it closes over another closure. So let's look at what actually happens. First of all, it still works. But notice that now it says I'm pointing to object 0, right? And if you go to the JSON, you will see that, let's see, context objects, right? And so now you have this additional thing over here that basically says, okay, you will need this other thing, this counter component, add value, whatever, right? This bit here, you're going to have to download yet another function lazily in order to make this thing work. So that call basically introduced this information, and this information contains a bracket 0 that basically says like, hey, that function internally is capturing this other variable. And so this kind of gets nested. Yes?
So is it fair to understand this, that you've tagged the placeholder value, which would be 0 in this case, with with the reference to the machinery you need to calculate it?
That's exactly what's happening. So if I click this button and I look at the network tab, what we get is, sorry, I need to see JavaScript. We get our closure, right? And notice that we have to restore the closures, the closed over variable, the lexically captured variables, right? And so we do this by calling useLexicalScope. And what the useLexicalScope does is it looks at this additional bracket, 0, and uses that information to go into all the data that's serialized and says, okay, what do I have to recover? What do I have to rebuild, right? And in this particular case, it says you have to rebuild this other function, right? So let me simplify this because this is unnecessarily complicated. So I'm just going to show this off, but let me just put it back as it was to kind of make it simpler. Okay, so when I click, I need to recover this count. This count in this particular case is a signal, right? So this useLexicalScope basically knows how to go into our QuickJSON, right? And inside of the QuickJSON, it knows to find this thing, this ID over here, 0121, basically says, you need to create a signal with a value of 0 for me. Okay, and then this particular signal gets passed into both of these entry points, right? So in that way, it simulates the situation where these two closures close over the same variable. So the hard bit that Qwik had to figure out, and what makes all of this other stuff possible, is that Qwik knows how to serialize a closure, right? Closure is a function plus data. We know how to take that and serialize it. And that's what makes everything possible. Because if you think about it, like what happened is this code executed at a server. And when this code was executing, we created a closure here. And this closure was serialized and attached to this button in such a way that on the client, you could just continue. And the thing that makes this resumable is the fact that the client no longer has to execute all of the components in order to figure out where the listeners are. It can just look at the DOM and be like, yep, I know exactly where the listeners are. Yes?
Just as a kind of follow-up summary, so it seems to me like the way you've defined, the program, the optimizer defines closure blocks, limits quite a bit the amount of polymorphism that can happen in that space. So here we've got 0. We need to trace back from 0 to this add, our add functions, and that's our option. We can't get lost. We can't go to another function. We can't go to another. We can't manipulate another variable because we have this.
Why would you say that? So let's create this polymorphism here. So let's say we have positive. Is that correct? Well, hold on, no. Oh, let's see if there's an add. Okay, here. And that's a count, value, number, count. Okay, count dot value plus value. Okay, come on. And then we can do subtract. minus value y. Why are you red? What are you not liking here?
Do you need? No, you shouldn't need to pass.
Comma
count.
expected. What? Oh, right. Because it's count value plus equals value, and then this is minus equals value. But you're still not happy. What are you not happy about? Oh, because sorry, extra parentheses. Okay. I was just complaining that nobody's using it. Okay, so then const adder equals random. Math dot random. There we go. So now the adder is one of the two cases. Okay, I'm going to argue that's polymorphic.
I totally agree.
Like, you have no idea what's going to happen, right? So this math random,
I would say you do have an idea of what's going to happen.
well, it's going to add or subtract, but you don't know
Yeah.
which way, right?
Based on your inputs, you do.
Right. So now plus is negative. As negative, it's positive, right? Like, you just don't know what's happening. And the reason for that is that this JSON, basically this function here will be one or the other. So right now it's the 690x4, right? And if I refresh, it's the other one now, voxk. And I refresh again, and it should be back to the original one. Yeah.
So this gets at the way I didn't ask the question because it's more confusing. But basically, you've now confused your coproduct space. You can't, with the way you've introduced the polymorphism, you've muddied the context of the operation by which you go backward by introducing the variable. So we can easily arrive at 0 via increment and decrement. But when you put in the random function,
Yeah.
we can't go backward along those because we've got the arrows start to get confused.
Yeah, but like it does work. Like it does exactly
it does work. But
what
I'm
you expect.
the question being that within the scope, we confine it to this small decision problem with how you with reference. We can still confuse the decision problem, but the scoping creates a very tight equation. And in that case, like, so we can confuse the coproducts here, but if we go back to your other one, we have a very clean space to do induction over.
Yep.
And that has to, so the question, just, and sorry I got lost here, but was the way that you're defining the scope of that, or I can't remember the word you used, it started with an S, I'm sorry, for the hash values that you're using.
Yes.
The way you've defined those gives us a way of saying only these number of things can happen between point A and point B.
That's right.
I got a
So
question.
yeah.
So maybe this is related, but it was only executing one of those functions every single time you press the button, whereas I thought mentally on the client side it would actually execute the random logic and then pick which one.
Right. So you're thinking about it from the point of view of React.
Yeah.
And in the case of a React, you keep re-executing the function over and over again. Here, we're trying to be smart and not do it. So in this particular case, so let me do a simpler version of this thing, right? So let's say value is math.random. And so if it's greater than 0.5, then it becomes 1 and becomes -1. And so here we're just adding a value and adding a value here, right? So if this was React, then this code would re-execute over and over again. So let's see what actually happens. It's always the same thing, right? In this case, it was negative. Let me refresh. Now it's always positive, right? It never changes. So let's see what actually downloaded on a network. So the thing that we downloaded was this handler function, right? We introduced this extra line over here, but we just really downloaded the extra handler function. If we go over to the thing here, notice that it no longer has 0. Now it has 0 and 1, right? Because what's happening here is now this closure closes over 2 variables. It closes over count, and it also closes over value. And that's why it says 2 over there. So now if I refresh and I go to my JSON, you'll see that it has both 0 and -1. Those are the two values that it's closing over, right? And this is how it recovers them. And if I refresh this, it might change to, yep, still -1. If I refresh this, it's still -1. Come on, do I have to apply for a lottery here? There we go. So now it becomes 1, right? And the whole thing works. Now, the other piece that is important about resumable systems is that they have to be reactive. This is why we use signal rather than use state. The problem with state is when we change the state in here using the set count, right? That component and everything below it is subject for re-rendering because you just don't know what's happening, right? Like, who knows what's happening underneath it, right? But that would mean that we would have to re-render too much. Basically, typically what happens in real application is that the state slowly migrates upwards, right, to the root component. And that means that your root component all of a sudden becomes the thing that you keep re-rendering over and over again, which means the moment the state changes, you basically just download the whole application. And you've basically undone all the hard work that we have done. So instead, what we want to make sure is that we are truly reactive, meaning that when you change something, we know exactly what we need to change, right? We have to have true reactivity. And the old joke is that React is not reactive, right? Like it looks like it, but it really, what it does is it reruns everything all the time in order to figure out what has changed. So when this was running on a server, we came across this count.value. We read the value property from that, and actually value is a getter. And so when the getter got executed, the framework learned that this template needs this value, which means it learned the fact that if this value changes, then this template has to re-render. So that creates a subscription. But we've gone a step further, and we basically said, hey, if this subscription changes, the only thing you have to do is you need to change the data property on object number 8. And if you go and look for that, it should be here, you notice that this object has an ID, 8, and it's currently 0. And so if I go and increment that value of that particular state, then the only thing I have to do is change the data. And so because of that, if I click here, the crazy thing is I've downloaded the handler, I've downloaded the framework. What I didn't download is the component itself. Like, it's just not needed. Yes?
So as you're clicking the buttons, with the on-click handler, you said the only thing you need to do is alter the data in that location. So is it patching that on the client side?
What do you mean by patching?
Is it essentially updating the data in place, or is it talking to the server, or is it all isolated?
No, it's all on the client, right? So it literally just gets a hold of that DOM text node and just says text node.data equals whatever the value is.
Would it be like the inner text or inner HTML? Or
I think it's actually data, isn't it? Isn't it? Like if I click here, and if I, how do I get the console here? So 0, right? Dot data. Yeah, so if I say data equals, like it's literally the data property of that thing. So what I'd like to do now is take this idea of signals a step further and bring other components into the view so that we can see what happens with other components. So instead of having a count here, let's make a new component called display. And let's make this a super simple component. And all we're going to do is we're going to return, value colon. And now here we would like to put the value. So, standard way of passing things in, we say props and props.value. Now, here we have to say what it is. So we have to say that value is, let's do the wrong thing first, just to kind of explain the wrong thing, and then we're going to do the right thing. So let's say you say like the value is a signal of a number, right? That's important. And then, well, hold on. So it's not confusing. Let's say count, and it's count.value. Okay, so let's do the wrong thing first. This is the wrong thing. This is not what we expect you to do. So then, instead of having this, you will say display. And so now you have to pass in a count, and you pass in the count like this, right? Now, why is this the wrong thing to do? Because you declared it as a signal. Like, it's going to work. It's going to do the right thing. You know, it's going to work the way you would expect. But it's the wrong thing because you're saying that you want a signal of a number. So if I, for example, say I have another display, let's have another display here, and I want to just say 1, 2, 3, it's going to complain saying like, well, 1, 2, 3 is not a signal. You asked for a signal for me. So the proper way to do it is to just say, no, I just want a number, like this, right? And then we don't have to do the value here. We just do a number. And so we do count.value, right? Because the count is a signal, so the value part is the actual thing. And so this also works the way you would expect, and you get the value that's directly available over there. Everything works as you expected. But here is the kind of the strange thing. So first of all, let's go back to +1, and notice that we download the code that we need. And sorry, this is Vite being Vite. 1 second, let me refresh. Okay, +1. We download only 2 things, right? We download the component itself, the handler, right? The thing that downloads, and then the framework itself. And that's because the framework was able to, in the JSON, in the subscription, say, oh, if you change the value of this particular signal, go update that thing over there. But if you're coming from the React world, you should be like, wait, what just happened? Like, how does this, like here we have unwrapped the signal, right? And so in here, we did the right thing. We kind of made this work. So let's say for a second that I say +1 over here. If I refresh the code and I do +1, notice from the network, not only did we download the listener and the framework, we now had to download the display itself, right? This is the thing that kind of unwraps it. But what I find interesting is that even though the value has updated, this particular thing didn't have to re-render. So even though I say count.value, even though it looks like I am passing a primitive value here, the system underneath knows that this primitive value is actually a signal. And so this doesn't get unwrapped, right? So that when a change happens, only the display has to re-render, not this component right here. So this component doesn't re-render, even though it looks like I'm changing a property over here. I'm not sure if I'm explaining this right, so you probably have a gazillion questions.
Well, one thing we were talking about during the break was, do you think it should warn you when it's about to unwrap the component and download all of its code to re-render? Because this seems like a really easy case to get into, right?
So as of right now, doing the +1, so if I do +1 here, right, it will have no choice but to download the component. So these, let's see, where is it? This is the hello world, right? So this hello world, there's div. So here, this is the component right here, right? It had no choice but to kind of rerun it. But this is going to be fixed soon. If the operation you do here is pure, like adding +1, we will be able to deal with that. It's only when the operation would be unpure where we just like, sorry, we won't have to do it. So we think we can get to the case where like good 95% of the cases we can handle. In general, like, is it a good idea to tell the developer that actually you're doing a de-optimization here? Probably, we could probably do that. It's not a, I would have to think about it if it's a straightforward thing.
Because it's not a deal breaker, but it is like a good to know type of thing.
It is, though, in a sense that, like, even if we do de-optimization, we're still like miles ahead of existing solutions, right? Because if you think about it, the existing solutions always run in a de-optimized way, right? So in that thing alone, we're doing the right thing. So the kind of the thing I want to point out is that we're very intelligent about the whole system, right? So in here, we cause the de-op here, but because here we know it's just a value, we never downloaded the other component, right? Like, so if I de-opt in both places, we will download both of the components. So this is one component gets downloaded here, and the display component downloads here. But if I don't de-opt in here, only the component gets downloaded. Only the top level component gets downloaded, right? So the system is pretty intelligent about like passing this stuff across. And in a case like this, where we can just pass it all across, we don't even download the components. We can just, okay, it's just double downloading again. I don't know why this happens in Beat. I apologize, let's restart it. We really only have to download the listener itself, nothing else. So my only point here is that the system is pretty intelligent about the reactivity graph, and it can go and update the right thing most of the time.
Yeah, so I think one of the things that as he was saying, we were discussing during the break, is when things behave differently when I change how I've coded it in an unexpected way, that when now all of a sudden it is downloading and running on the client and I'm getting different behavior, that's I think gonna surprise a lot of newcomers, especially. You're doing a great job of calling out, like, comparing it to the React mental model, because most people in the community have been steeped in that for quite a long time. So I think it's a good kind of analog to continue to draw. What was interesting is the reason the display value was changing was not from a React perspective that the props were changing, rather there was a direct reference from when this signal changes, I need to update this part of the DOM, and I know that because that's how the code executed on the server when we serialized everything. So I think driving those kinds of points home might help to get people to shift their paradigm and kind of appreciate some of what's going on here.
We would like to get to the point where we are like solid in the sense that we execute this exactly once and there's no surprises. We don't know whether it is worth the trouble as of right now. So that's kind of the situation we just happen to be in. But yeah, an excellent point. I totally agree with you. Your mental model just has to be adjusted for the fact that, like, the component function may or may not execute. You just don't know, and so you better make sure that it's idempotent if it does. Yeah.
Here's something that could resonate. Are you saying that I don't need to worry as much about memoization?
Correct. You don't.
That's amazing.
You do not have to. So the standard, right? So the standard memoization kind of a thing is the clock demo, right? Clock. Let me just add a clock here. Const clock equals. What is it? Const time, the signal, new date, look at that. Use client effect. And so in here we do, yeah, is that all right? Yes, but here we want to just do in string. And so here we want to do .to locale time string. No? Why are you not happy?
Do you need to wrap new date in?
Oh, sorry.
No, just.
Oh, there you go. Yep.
Okay. Well, it's And then here we just do return. Okay, so this would not work in React, right? Like the issue here is that the React would assume that the value is always the same thing, and so this clear interval, I think, just accumulates over time, and you just make a mess out of the system, right? So in that sense, we're more like solid. Like you just don't have to worry about the memoization in that sense, and that's nice, right? It's a nice property.
I mean, that's more than nice. I feel like I spent the majority of my time reviewing code and fixing places where people were not doing memoization, missing exhaustive depths. We had custom lint rules that would catch exhaustive depths that were nested objects. Like, it's a huge pain point. So, yeah, that's awesome.
Yes. So that category of things just should not be an issue in signal-based systems, right? Because the reason why this is the issue, right, is because React always reruns the code over and over and over again, right? And that means that you like set intervals or clear intervals, accumulate, etc.
So more of a clarification question on line 18, where you had the display. Yeah, in this code base, but on our page. Line 18, line 24, where you have the display count.value. So is the lesson here that there'll be some assumption, if we give this a stream, it will assume it's a stream, it will wrap it in a stream, or it will think it's
Yeah,
a
so
stream
let's look
wrapped
at
in
what
a stream?
happens under the hood.
Because the follow-up question is, when you put in +1, right, you're no longer expanding by a constant, you're expanding by an operation on a constant.
Yeah.
And is that the kind of confusion point?
That is exactly the
Okay.
thing. So let's refresh this. Let's see, network. And we downloaded not the clock, the counter. Right, here it is. So here is our display. And notice the read was wrapped in a getter. So that read is actually delayed. It's not an eager read, it's a delayed read. And instead, we create an additional property which says, see if the count is a signal and try to read the value off of it. And this internal stuff is what basically says, like, is it a signal? If so, I know how to do my magic without actually causing a read. Because if I cause a read, I'm essentially creating a subscription. And I want to avoid the idea that there's a subscription over here, right? I want to prevent that, because if I do make a subscription, that means it has to re-render all the time, right? And so I'm trying to say, like, I know it looks like I'm passing the value over here, but I'm not eagerly reading it, and therefore it's not a subscription.
So in the case of Qwik, for like line 25, subscription and functional dependence would be mostly overlapped. The two concepts, where if you have a functional dependence, like the plus sign
Yes.
on line 25, you also have that would
Yes.
equate to a subscription.
But the thing we're trying to do is we would like to create a transformation function as part of this thing, right? If I was able to just pass in a transformation function in this location and says, +1 is happening here, then the whole problem would go away, right? And the requirement is that transformation function has to be pure. So if I can, at compile time, detect that it's a pure transformation function, then I can just inline it in this location, and then the whole problem just goes away. And in 99% of cases, the right stuff will happen. Yes.
But it's the guarantee of purity that needs to be
Yes.
needs to be in place.
Yes.
Okay, thank you.
Yeah, the other realization that's dawning on me is all of the complexity that we deal with in React with, when you're using React hooks and you have to call out specific dependencies, and you have this process of nested context, trigger re-renders, and things like that. All of that complexity goes bye-bye.
Yes. Yes. So actually, let's go and explore that a little bit. So first of all, before we go explore that, let me show you some particular thing that I've done here. I said props.count. What I specifically didn't do is I didn't do this. Oops, I didn't do this bit. I could do this, and it is something we're still working on. But what happens is because we read the property before we get to the JSX, we don't have a chance to intercept it. And so now you've created a subscription, whether you liked it or not. Application still works exactly as you intended, but actually, let me get rid of the clock because it's just confusing the situation here. It still works, but if you look at what's being downloaded, is that we are eagerly downloading this display, right? Because we don't actually know what's happening to that thing.
Just because of the destructuring?
Because the structuring is causing a read, right? And we are working on a, we haven't decided yet, but this will either become a lint warning saying don't do that, or we think we can transform it into, during compilation, we can transform it into something reasonable. So as long as you don't do a read anywhere else, we'll consider that okay.
I was going to say that latter option seems vastly preferable because, in terms of readability, as you're working with the code, we use object destruction all over the place on.
So again, you can do that. The application works exactly as you would expect it. You just end up downloading slightly more code, right? So, but even in this situation where you're downloading slightly more code, again, you are miles ahead of hydration. Right? Because you've only downloaded a tiny portion of the whole thing. Now, let's undo this bit and go props count. Okay, so let me show you another important bit. So let's say we actually print the count directly here. And let's say we cause a de-optimization by doing a +1 on here. And V is confused again. Okay. So, why do I have a clock in there? Oh, the clock's in there. That's what's happening. Okay. So when I click this button, we obviously we have to download the entry points. We have to download the framework, and now we download the top-level component, right? So we download this component right here. And this component has to re-render. It does no more rendering, right? This component right here. But notice what didn't download. What didn't download is the display, which is a child. And this is an important point because in normal systems, when you get a hold of a top-level component, you're getting hold of all of the children below it, right? And in this particular case, Qwik was able to say, like, you have this component in the middle of the tree. And I can wake it up independently of its parents or of its children. And at first you might say, like, well, the parents is easy, right? Not so much, because the component may have props from the parents, like things like children, right? And you don't want to force waking up of the parent just to get its props. And at the same time, you don't want to force waking up of the children just because you are re-rendering, because maybe you just happen to be a component that's high up in the render tree, and you don't want to cause all the stuff below you to get downloaded. So the reason why all the components are wrapped inside of this $sign here is so that we can refer to the display component without actually referring to its content. So if you look at what actually gets downloaded, let's see, children, where's our display? Here's our display, right? We are referring to display here. But if you look at the definition of what the display is, I think if I go here, if you look at the definition of display, it just says, like, yeah, dynamically import this thing if you need it, right? And so it's not just about breaking up your listeners. It is also about making sure that if you get a hold of a component in the middle of the render tree, you don't automatically force the download of the children as well, and you don't automatically force the rendering of the children as well. And again, existing systems can't do this because, yeah, there is a way to say don't descend into children in existing systems, but at least once at the very beginning, the framework had to descend to the children to kind of figure out what's in there, and then subsequently it doesn't have to, right? And the fact that at least once it had to do, you've already lost a particular game, right? Like you've already eagerly executed the code, and so you have a problem. And so those are kind of all of the main pieces of this system. Let me just pause here, see if you have questions, and then we can go other places.
Well, this sort of relates to, have you guys been thinking about developer tools to help with understanding when you're de-optimizing, and also a little easier to navigate the DOM versus looking at all the comments and parsing the comments mentally?
Yes, so there's a couple pieces in there. So first we have ESLint. Like you've seen, like if I forget to export this particular bit, like technically I don't need it, like it complains and says like, actually I might have to move this, and if I move it, I'm gonna have a problem, so make sure you make this exported, right? So we already have that. There's also a dev tools in here. We don't quite have that yet, but it is something we are thinking about. Again, early time of the project, right? So not the whole world can be done here. We have one open source contributor who did this super cool thing where you install a special plugin. I think if you hit the control key, and then all of these things become clickable, and then you can click here, and it takes you to the source code and VS Code to a specific line where that particular thing is defined. That is super cool. That works as well. So we're getting there, but it's a new project. But for the most part, because it uses JSX, and because the transformations we do is just moving code from point A to point B, and then we add a little header, we don't actually touch the code itself. The source maps work as you would expect. The debugger works as you would expect. There aren't many surprises in there. The only thing that's strange about debugging is that, well, you can't, the way you put a breakpoint somewhere is you navigate to source and you click on it, right? The problem is no code has shown up yet. So you need to do some operation in order to get the code to show up, and then everything works as expected. So for example, if you place a debugger, right, this is literally the code you have written. If you look around, like this is what I wrote. Nothing in here tells you that actually the code that was downloaded was just this bitty right here, right? And the point I want to make about the breakpoints is that if you look at your variables, the local variables, none of them here will in any way hint that the transformation happened, because we're not moving the variables, we're not creating extra variables, we're not doing any of that stuff. We're just putting the little header in here. I think the only thing you'll see is that this count is, if it would be truly captured in the global scope, there would be like a parent thing over here that you would have an extra place. But other than that, you have a count, you can change it, you can see its value, etc. So the debugger experience is very, very normal. You do have to understand, though, that, so let's say we want to place a debugger inside of here, which we can also do. Oops. Right? This debugger, we will never hit, right? So no matter what I do, what's going on? Yes. Yes. Okay. I didn't hit the debugger statement, right? And the reason is because that's on a server, that's not on the client, right? So you have to understand that, like, okay, let me just, dev.debug. So I'm going to run the server in a debug mode now. Now I can open it up, right? And here, now I will hit it. So here we go. Now I hit the bit that I expected. I'm not sure why the source maps are not here. Source maps should be here as well, just like there in the browser, right? But the source map should apply, and you should see the same exact stuff. So in that sense, it is more complicated because you have to understand that some code might execute in the server and some might execute in the client. And sometimes it executes in both places, right? So if we close a deopt and the function reruns on the client, then now you're going to also have to be ready for it in the client. So in that sense, it is a slightly different mental model. But the debugging works the way you would expect. Like nothing there is changing. Let me get rid of the debug mode here. Come on. Oops. Okay. Oops. Okay. So here we have the code, and if I can click +1, right, it updates. But by updating, I have now created a count in my window. Remember, I assigned it. This particular thing, I assigned it to the window, so I got a hold of it. And this is what I mean by the system being reactive. If you go value and you say equals 1, 2, 3, it just goes and updates that. Like, this is what we mean by system is truly reactive rather than, sort of reactive like React or Angular. Yes?
So, I'm sorry, I missed the part where you implemented the binding to the window. Can you go back there?
Yeah, I just took the count and I just assigned it to the window.
Okay, so curious, because in other environments that handle SSR or SSG, you have to explicitly test to see if window exists in order to not throw an error.
Correct.
And break the build. So here you don't have to worry about that?
Well, this is a click listener, so I know the click listener will only execute in the browser. It's impossible to execute it on a server.
So that's how you were safe doing it
yes.
within there.
But yes, you would have to do that.
You would have to do that if it was outside of a click listener.
Yes, so and that's also why I didn't put it here, because I knew that at this point, this is going to execute on a server, and so I know that this isn't going to help me, right? So, and it will break. And so there, you can import, you can say if is browser,
No,
this is not. What is it?
You can do type of window.
Yeah, but like we actually have a thing for you, but I don't know why it's not coming up. I think it's import is browser. I'm not sure why it's not completing. No, that's not emotion. I don't even know how did you get emotion here? Is it build? I think that's what it is. So now this is safe, right? It says you only execute this if you're in a browser. And so, it will work exactly as you expect, and I still have access to it, and I can just say,
Interesting.
Another Reactism, can you do the if statements interspersed with use?
no.
Okay.
That is the same rule.
Same, okay.
Same rule. So you can't not do that and use signals. It also means you cannot have a promise up here. So you can have promises inside of your JSX. That's fine. But you can't have an await statement before the return. The JSX must be returned synchronously. Inside of the JSX, it's fine to have promises, but not that it has to be returned synchronously, right? Again, it just happens the way how nothing in the framework itself requires it, but that's how the use methods work, and so we kind of just follow the same convention because we don't want to have yet another thing that's different. So, yeah.
Sorry, I keep on trying to orient myself to the world of React because that's what I've been swimming in for a while now. And I'm sure a lot of the audience is too. My question is, in React, one of the cool things that I think helped people to adopt it and use it is the developer tools and now the profiler, because you need to be able to analyze and understand what's going on under the hood. But because, if I'm not mistaken, there is no shadow DOM, right? Mm-hmm. So you no longer have that mismatch or that duplication. And you don't have the flame war in the flame graph of the optimizer. Mm-hmm. So is there even a need, or would there be any kind of a benefit for a Chrome extension or something that would provide quick specific? I'm just trying to imagine what that would even look like, or where the benefit would be, because the reason why those extensions exist is to solve a pain point.
Yes.
Well, you've eliminated a ton of the pain.
I did yes. So all reactive systems, this is not specific to Qwik. If you go to solid.js, the same benefits will apply because it's truly reactive system, right? All reactive systems will have this benefits. Having said that, developers are creative. And so I'm sure we can figure out a way to make something slow, even if remove a bunch of pain points. So I think there's always a need for understanding what's going on. Like that problem never disappears. But as you can see, many of the common pitfalls just aren't there, right? You just don't have to think about them. They're not there. the way the reactivity works, as you can see over here, that you can just assign to it and the right stuff happens, is it's kind of a mind shift. But because you have reactivity, then this whole clock business goes away, right? The clock business problem, the set interval problem, is a problem that reactivity just kind of solves and says, like, you just don't have to worry about it. It's just not a thing, right? And by the way, I know I showed this yesterday, but let me show you the clock again. I just love this demo. I say div, and I'm going to say style, height. Right? So clock's below the fold. No, nothing is running. When we scroll the clock in view, JavaScript shows up. That is just a beautiful demonstration of like how just out of the box the framework forces you down a particular path that is just like that's the path you want by default, right? You shouldn't have to think about it the other way. Now, I can pass in another variable in here and say, actually, I want, let's see, what is the value? It's eagerness is eager. I can say eagerness. Like, is that the right? No, it's visible. Oh, sorry, not visible, load. There we go. I can say load, and in this particular case, when I come here, you see the code just immediately loads, right? It just is eager because like you said you wanted to do it eagerly. But I think it's a nice kind of demonstration of like, just out of the box, the right thing happens. We can now talk about like, well, what exactly is happening here? Come on, why is, okay, sometimes that happens where the DevTools just gets confused. Okay, so let's.
It's developer tools crashing. You have to close it and reopen.
So let's just reload it. Okay, here is our div. So notice what is happening here is the way Qwik works, everything has to be an event. It's all about the events because the events is the thing that drives the system. And one of the things Qwik does is it just tells you what events exist in a system. Right? When we server-side render, we know what events we saw. We saw a click and we saw a queue visible. And this is how we're telling the Qwik loader, like, watch out, those two events might come. Now the queue visible one is a synthetic event. It is not a real event. And so the Qwik loader understands that it has to create an intersection observer for this particular thing. And then it fires this particular event, right? So if I say in here, for example, click, right? When I scroll down, the time no longer does anything because it's waiting for a different event, right? But when I click on it, the time shows up. There's the delay because the set interval waits a second before it actually updates. Actually, the proper way to do this is, say this is update and const update equals this, and then we have to run it eagerly before we wait for a second, right? So now the right thing just happens. It immediately shows up. Okay, so that's use client effect, and our convention is to have the word client, meaning that we're guaranteeing you this will only run on the browser. So you don't have to worry about this ever executing on a server. But let's say we can do other things. For example, let's say the clock, actually, let me, let's kind of start from scratch. There's so much stuff in here. All right, let's just delete all this. So we have a signal, we have a count. I'm just simplifying the whole thing again. Okay, let's go to the simplest possible case here, right? Let's say we now have a new one called double count. If I could spell. And so not only do we want to print count, we want to print slash double. When people are watching, I cannot type. Okay. So let's see, where are we? So we have a double count, and obviously, this won't do anything, right? We'll only update one of them. Oh, by the way, an interesting bit right now is that if you look at the state of the system, what got serialized, quick JSON, and let's make the double count just for fun, 1, 2, 3, just so it's easier to find. Notice that 1, 2, 3 never got serialized. If you look at all the data that got serialized, 1, 2, 3 is not part of it, right? Because the system looked around and said, like, well, there's no way for you to change it. Like, why do I bother serializing it, right? Now, if I, for example, cause a deopt, as we said earlier with the +1, and then I refresh it again, now the 1, 2, 3 is in there. Because now it understands that, like, hey, I'm going to have to re-render the whole, I'm going to have to rerun the JSX. And because I'm going to have to rerun the JSX, I'm going to need that signal. And so now it's there. So it's kind of just interesting how automatically, without any effort, the system just does the right thing. But what we want to do is we want to make sure the double count is twice of the regular one, right? So you would do this in use client effect in React. The trouble with the use client effect is that it always runs after render. And I think there's a case to be made, like, well, sometimes you want to run before render and sometimes after render, because, like, if you're on a server, you want to delay the rendering and compute the double count before you actually continue with everything, right? So we could do it as a use client effect, but I think that misses the point. This is not what we actually want. What we want is we want to basically create a use watch, and use watch is just like use client effect, except it also runs on a server, but specifically it runs before the rendering, right? And so we can say that double count value is equal to count.value times 2. Okay, now that's nice, but this isn't going to work because, well, I mean, it is going to work in the sense that let's start with a initial value of 10 here. Notice that it correctly does the work, right? We can be even more fun and say await, async, and we can do delay 1 second. So now I have to run my delay function again, which I lost. Value milliseconds. Love this thing. How does it know that? I have no idea. Value t. There we go. Okay, so now we have to put await, right? So why is it? Oh, because it's forgot to do export. Okay. Notice it still does the right thing. The server understood that, hey, there is a delay. Did I put 1,000 delay? Why don't I see a delay in rendering? Oh yeah, I see it spinning and then it renders, right? So there is a delay that happened on the server because that's what I asked for, and then it computes. So use watch is kind of like use client effect, but it runs before rendering, not after. And if there's a synchronicity, it actually blocks and waits before everything continues. Yes?
2 things. First of all, could you scroll up? Because when there was an error being thrown up there.
Oh.
Why are those errors throwing? Oh, it just
they were unused, and so the system's
Gotcha.
complaining that you have unused imports.
Okay, so then use watch essentially is along the lines of like a get server props.
It doesn't have to be. It just executes. Well, this is incomplete, actually, implementation. Let's just finish implementing it first, because notice it doesn't work.
That was my other concern, is that you were when you initialized the double count, it had, if you scroll up a little bit, it had 1, 2, 3 as its initial value.
Yes. But then this overrode it, right? Okay, so that's because this is guaranteed to run before rendering. Unlike use client effect, which always runs after rendering, right? So we make a distinction of before or after. Like React World is just like run after rendering and then cause another re-rendering to happen. It's like, yes, but like that doesn't work with streaming, because one of the things that Qwik really wants to make sure it works is with streaming, right? And then when you have a use client effect, and if you have something like this where you wanted to load data or compute something, you won't be able to do it. Now, this thing is doing the wrong thing, because it doesn't update this number, right? And so what we need to do is we need to tell it about it. So there's a special function called track that you can import. And then in here you just say, I want you to keep track of count. And now, oh, because of this delay, it's causing a delay in rendering. So let's remove this delay. Let's just say 1 second. You can see that they're now in sync, right? So the track is the way you tell so in React, you give it an array on the end. But the problem with that array is that assumes that the main function keeps running over and over and over again. But in our world, we don't have that guarantee that the main function runs over and over again. And so we actually need to know what you passed into us. We need to create a subscription. And so that's why you're using the track method to create a subscription. And that track method, if you think about what's happening, is this useWatch executed on a server. So here, let's put a console.log. Oops. Double count, yeah, perfect. So notice, on a server, it executed, right? But then if in the client, and if I go to console, it executes on a client as well. So now you have a piece of code that executes both on a server and on a client. But when it executed on the server, the track created a subscription to this particular thing, right? So on a server, there's now a subscription that we know about. So if you go here and we look at the subscriptions, we know not only do we have to update some DOM location with it, but also we have to update a second signal with it as well. And so the subscription information got built up on a server so that we know, like, oh, if you change this value, not only do we have to update the DOM, but we also have to update the second subscription, which then causes another DOM value to update. Yes?
So if you could go back to the code again, because I noticed you're using object destructuring on line 14. That, I imagine, would be a safe place to use it because it's operating on the server.
It's the APIs that we have given you. This is not any props of the component, right? Props of the components are the only place where the destructuring is problematic. Okay, so let's do one more thing here. So we have our onClick here. And I want to do again, window as any count equals count. So I'm going to write it out over here again. And the thing I want to point out is if I do count.value equals 1, 2, 3, let's say, notice not only did the DOM update it, but the constraints between count and double count also updated. Right? So the two parts are now coupled and tight. And this is what I mean that I'm saying that if you want to have resumability, true reactivity is a requirement. Right? Because if you don't have this, then the answer becomes like, well, just recompute everything, and then all kinds of crazy stuff happens. I'm going to point out one more interesting thing is that currently we're talking about signals, but there's other way of doing this. So we can, for example, talk about state, and then we can say use, store, sorry, store, not state. And so in here we can say count is 0, and then we can say decount, double count is whatever, 1, 2, 3. And now we can delete this. And then now we track store.count is what we care about. Oh, and I think we have to pass in a closure in this case. And then we have store. So we don't need to do this. We can just say store.doubleCount, store.count. No. Store.count. no, start double count, right? Use store has to be imported. Store done. Okay, same exact thing, but instead of using a signal, we now have a store. So what's different than a signal and store? A signal, the idea behind signal is that you have a bucket, a closure, basically something that has a single property called value that represents what you want, right? Whereas a store is an object just that has properties. But whether you're using one style of doing things or the other style of doing things, it works exactly the same. There is no difference. As a matter of fact, under the hood, a store is just a collection of signals, right? So same exact behavior we have over here, and I can say store.count equals, let's just do count plus plus. It will update, right? But notice if I do store double count, I will update the double count, but not, the watch didn't run because I specifically said that the thing I'm trying to track is just the store count. I'm interested in the count changing, and that should trigger me rerunning, not the other side around, right? And okay, so right now we are getting hold of the store by clicking a button, but I can do another trick. I can just say use client effect, and I can say that, oops, too many curlies, window as any dot. Okay, so I can eagerly export the store, right? So even before, obviously the client effect code had to run, right? But now I have a store, and I can go and update it, right? So it just becomes interactive from the get-go. Okay, where are we with
Would this functionality provide what would pass as some sort of memoization in the system, or would that be better thought of differently?
No, it's totally
Okay.
memoization, right? Like you don't have to worry about it rerunning all the time. And a typical use for like use watch is, for example, let's say you have like, let's say you want to know what the weather is like, right? So you have the user type in zip code, and a change in the zip code triggers a watch to go talk to a some service, some HTTP fetch, whatever, right? And then that returns and updates the data. And not just you have a track, you can have a cleanup function in here. I forget what else do we have here. Use watch is watch function, which, oh, sorry, it just takes track or cleanup. But it can be asynchronous, right? So you can delay stuff, or if you don't want it to be asynchronous, you just return eagerly and then do the asynchronicity in a separate path. So you have all the choices. One of the things that I think is important is when you're building things in React, everything is fully synchronous. So there are no surprises of like the order in which things happen, right? It's always predictable. And because everything in Qwik is synchronous, we actually go through a lot of trouble to make sure that even though it's asynchronous, it will always execute in the same order. So we won't go through all kinds of trouble to make sure that things look synchronous to you. And this is done intentionally, and you can always, as a developer, escape that by just creating a promise and doing whatever you want over there, right? So, but out of the box, we want to make sure that it's predictable. Now, that actually kind of points out to another interesting bit, which is that when you render a component, you want to make sure that you don't see intermediate values. If the operations you're doing are asynchronous, you don't want to see intermediate values. So the rendering pipeline actually collects all of the updates to the DOM, and it waits until all of the promises are resolved, and then applies everything at once. So you don't get to see intermediate values in between. Before we change topics, any questions? Yes.
Yeah, you can defer this until we get more deeper into streaming, but is the page interactive as it streams, or do we have to wait until it's fully streamed to be
Let's go and talk about it. Let's go and talk about it.
Because you're showing a delay here, so that's why.
Yes. So here is an application was built with our friends on Cloudflare, and you can see how it's streaming the body. Right? But I want you to notice that there are boxes in here. There's the red box. There's the blue box on the bottom, and you can actually click on it, I think. And what's happening here is each of these boxes is a separate container. So let me show this to you again. So notice how the container is paused. There's a container representing the big app. There's a container representing the smaller application, and currently it all says that it's paused. As a matter of fact, I believe there's 4 containers on this application, if I remember correctly. Query selector all Q version. Right? So we have the HTML, the body, the header, and the footer, right? Those are the separate applications. What's actually happening on a backend is these separate applications are rendered at different URLs. And then there is a kind of the multiplexer, the kind of the root container that talks to the other applications and assembles everything together. And because of that, there's an interesting property, which is that I can interact with the top before the content even shows up on the bottom. And that's huge, right? Because you can't do this in the normal world. Like, you have to wait for hydration to fully download, fully execute, and only then can you interact with it. And so this, I think, is a kind of a huge improvement. The other thing I want you to point out is, as of right now, okay, they all are running the same version of Qwik, but it doesn't have to be. But notice that the URLs are different. They're actually coming from a different URL. Actually, let me show this to you on our homepage. So on our homepage, we have this header over here. Let's just zoom it out a little bit. We have this header over here that is rendered as part of our documentation website. But then the landing page is actually rendered as part of Builder.io. So this Builder.io provides headless visual CMS, and then you can drag and drop and move things. And we want our marketing department to easily go and edit the content that's on the pages, right? So what happens is the top level thing is a Qwik version over here. Actually, it's resumed. It doesn't have to be. Oh, it eagerly resumes. That's interesting. There's a top level container here. But if you go into like this place, you realize that there's a separate container right here that's paused. And notice the version here is not the same thing as the version here. Not only is it not the same thing, the Qbase is the location where the code should be fetched from is a completely different server. Like, this app that's embedded inside of it is fetching code from a completely different place than this location over here. And of course, there is a ServiceWorker that knows how to deal with all that stuff and prefetch all that stuff, so you don't have to worry about it. All right, so let's get back to, we talked about containers, right? So in this example, right, we have multiple applications. We have the HTML, the body is another app, the header is a separate app, and so on and so forth. And as soon as the container gets closed with the Qwik JSON, right? So each one of these containers has its own JSON. As soon as you have the state of the system, that particular container becomes resumable and you can start interacting with it. And that's why in this particular case, as soon as the menu shows up, even though the rest of it is not showed up, I can start interacting with the page because only that component is resumed. The other kind of cool thing to kind of think about is that the individual, we call them containers, are fully contained, right? So what I mean by that is, let's say I take the container here And I can't right click because the thing crashed again. Let's try this again. It happens sometimes that the dev tools just crash. Okay. So let's go to the header, and if I make a copy, and then let's just make multiple copies of it, right? We can just go and interact with whichever one we want, right? So the HTML alone fully defines the application. So to put the application in your output is a matter of just concatenating the HTML, because that HTML fully contains location of where the fragments are, where the code gets downloaded. It contains information about what to prefetch, how to download it. It contains information about what events you listen to. Basically, everything about that app is fully contained in that HTML. Yes?
So essentially that's an encapsulated state.
Yes.
And I guess I'm confused because aren't there ID references, quick virtualization ID references embedded in that? So when you duplicated,
it's all scoped down to the container. All these references are local to the container.
Interesting.
So
okay.
you could have two IDs pointing to the same thing. It's not a problem.
Interesting.
It's scoped to the container.
Interesting. Okay, so now let's say we live in a world where we've got a requirement for framework agnostic serving up of components. So like, what if you had like that footer, you wanted it to be an Angular app, and another one like the body or something within being a React app or a SvelteKit app? How would that look?
Right.
Is that possible?
So Qwik is friendly in the sense that it doesn't just randomly change your DOM structure, right? The DOM structure is built by the HTML, and for the most part, unless you specifically tell that you want to delete something or update or delete or modify it in some way, Qwik will not touch that DOM. And so in that sense, it's very friendly to coexist with others. How exactly you bootstrap the other framework, that's up to you, right?
But your root DOM node, that client-side rendered React app could register to, could be nested somewhere.
Yes. So Qwik will not like actively destroy or move DOM nodes or anything like that. And that's kind of a side effect of resumability, because we can't move things around, because if we did, what if later we need to wake it up, and then by moving it we would kind of destroy our ability to do so, right? So that's just a natural consequence of things. And so as long as you can guarantee that the other framework will not mess with the DOM structure, Qwik can be embedded inside of the other framework as well. And because everything is scoped to the container, you can have as many copies as you want, or you can put it anywhere you want on the page. So like I made several copies of the header up here, but I could put it on as behind the footer. I mean, I can just go and replace the footer with the header, and can I click outside, and now I just have a header at the footer, right? And it's fully interactive, just like all the other ones, right? Because the HTML, or rather the DOM, is the source of the truth. And so this property, I think, makes it extremely useful for microfrontends. So one of the kinds of the microfrontends we would like to do is personalization. And personalization of, let's say, e-commerce website. So here's an example of e-commerce website. And it looks like a normal site. Your reviews, products, there's your shopping cart. You can add an item to the shopping cart, like it shows up over here. There's items in here. Like in that sense, it's a pretty straightforward thing, nothing special. But the way it's put together, I think, shows off the kind of the power of the whole system. So let me click on this button that says Show Scenes. And what it shows is that this application is broken up into containers. And specifically, there's a header container in this URL. So Qwik Dream Hemo, so Qwik Dream Hero. Okay, I can go to the URL and it serves up just the hero image and nothing else, right? So this, where did my here? this hero section over here is literally the same thing as this thing over here, right? Here it doesn't work because the quick loader is not loaded, but here it works because the quick loader is present here. And what's happening here is that we hit the root edge worker, and the edge worker, has to compute the output. But the single edge worker doesn't have the computational power or enough time to actually do this, so it branches off and says, I need a header. So the header, or rather the menu, as you can see over here, is Qwik. There should be menu. Is a completely separate worker. And because the menu is always same for everybody, this worker sets the cache such that it's cached for a whole week or something like that. I don't know how long it takes an update in the menu, right? So when the rendering is happening at this level, at the root level, the service worker says, I need a menu. And the menu just responds from the CDN and says, here you go. But notice that the menu over here does not include shopping cart. The shopping cart is a separate service worker. So then you go to the shopping cart and says, service worker, I need your response. And the shopping cart is obviously specific to the user, so that can't be cached in a CDN. And then it has to do a full render. But it's not rendering the whole page, it's really just rendering a tiny sliver of the application, which is the shopping cart, right? And then you go to the hero, and then maybe you say, different people have different interests based on the cookie that you're logged in. So maybe you come here and we say like, oh, you like 3D printing. Let me show you, let me go fetch from a sub worker, edge worker that knows how to return a 3D printing hero image. Because if you think about it, end of the day, your marketing has created limited number of hero images or hero banners, right? Maybe there is 1,000 of them. It doesn't matter. At the end of the day, it's a limited set. And so after a while, you essentially have just cache hits for every single one of those hero images. So to render the hero image is extremely cheap because you just go hit the CDN, it comes back, and the hero image is fully interactive. It can do other things. It's not a static piece of content, right, that just shows up. And then the same thing happens with the shoe, right? So the personalization becomes either do a full render for something small like a shopping cart, or choose one of n for more complicated things, such as hero images or product placement ads or anything of that sort. And finally, you want to print out what's below the fold. And so if I actually let me refresh this. Oops. Let me go here. And if we go and disable JavaScript, and I refresh this, notice that it doesn't actually have the shopping cart, so the reviews. It says loading, right? Because this particular component right here, C has unvisible, right? So what happens in practice is if I enable JavaScript, it's only when you scroll to that position does the content actually shows up. So you're solving two problems. First of all, you're delivering less content to the browser, so you're faster that way. And second bit is that many parts of the stuff that you're delivering are cacheable, right? But what's not cacheable is the overall page. But that requires that things are assembled. And so assembly in Qwik is essentially trivial because it's just concatenating strings. But when you, for example, add an item to the shopping cart, clicking here updates your shopping cart over here. And that's across going between containers. What's happening here is that clicking this button is firing a custom event. And because events is one of the things that we can serialize, the shopping cart can listen to it. So let me show this to you in a slightly different way. Let me refresh this. Let's find the shopping cart. And the shopping cart is currently, so for some reason they care about visibility, so it's eagerly resumed. So the shopping cart is already resumed, but notice that the shopping cart is listening to onDocument session token received event. I don't know why they named it that way, but order change event. This is the event that they're looking for, right? So the button here fires an order change event. If I click here, let's go to the network tab. Clicking this button looks like, yeah, that sets an order, and somewhere in here we should see that we are sending a custom event. Can I search this? No, I cannot search this. Oh no, I should be able to search. What was the name again? Custom. Well, I don't know where it is. Somewhere in here basically just says, you know, dispatch. Oh, here it is. Look at that. Dispatch custom event, right? So just saying, look, I'm dispatching this event. And within, I am passing the correct information that the system needs. And because everything works on events, that automatically goes and wakes up this container right here, right? And this container is listening for this order change event, and it has a handler that executes and wakes it up. So you have inter-component communication, but it's not just component communication, right? You still have this property that the container is not resumed, and what resumes the container is the event. So everything here is event-based. So the way the containers communicate is the one container just fires off an event into a document, which is a commonplace, and then the other container can listen to it. And the way the listening happens is purely just by this attribute, on order change event, right? That attribute alone is the thing that sets this up. I see. So the last bit to kind of understand is that somewhere in here, oh, here it is. Somewhere in here, we have to tell the system about it. So when the container shows up, it basically tells the quick loader that, oh, by the way, I expect this event. I don't know if it's going to happen or not, but I don't want you to eagerly wake me up and allow me to run some client effect or something like that to set up the events, because it might never be fired, right? So all I really need to do is to tell the quick loader, like, this event may happen, and then you can do whatever is necessary to kind of get it up, get it kind of configured.
Yeah, so now taking that one step further, what if you made the quantity within the cart adjustable?
Mm-hmm.
Would you have to do, what would change, or what would need to change in order to make it so that it would be bidirectional?
The shopping cart would have to just fire an event, right? That's it. You fire a custom event with a custom name, and then you expect that somebody will listen for it. That's all. And
you can reuse the event name.
You sure? Yeah. You will probably also receive it yourself, but yes, it's just events that on the end of the day was always happening. It all comes down to the fact that the way you listen to events is you say add event listener on a DOM. The way you listen to events in Qwik is that you add an attribute in the DOM. And that's a huge thing, because it means that just by the presence of the attribute, the event will be received. And you don't have to eagerly execute code to say that I need this event. There's no eager execution of code, right? It's just, you just declaratively say, I want this event. And only when this event happened does it wake you up and execute this.
Is it fair to say that our listeners, effectively, when they know what to listen for, we've ensured that they know what to listen for, and they can, for lack of a better description, they can look down and say, this is the thing I need, and that field is uncluttered.
Yes.
They have an instruction, they know what to listen for, and they know how to dispatch a response from that tag. Is that fair?
Yeah, so as a developer, right, let's kind of play with this a little bit. Let's go back to our demo. As a developer, we still have our, okay, we're playing with our, I'm just going to simplify this thing here a little bit. As a developer, the only thing you really want to say is use use on document, right? And so let's say you say I want a custom event called foo, and if the event happens, I want to do console.log. Why are you red? Oh, sorry, because it has to be wrapped in here. And for some reason, this does not auto import. Okay. Okay. So this is kind of like this is the equivalent of add event listener, right? That you just did. What's unique about this is that this code executes on a server. It's at the server time when we are setting up add event listener, and then it comes to the client. Now, nobody's firing this event, right? But if you look into the generated code, it's not here, that's the JSON. Here we go. So it says, I care about foo. Like, it noticed that you set up a foo listener, and so it says, I care about a foo, and of course I care about a click. And so no, where is the network tab? No JavaScript whatsoever here, right? No JavaScript is present. So let's fire a event. So document dispatch event, new custom event. And I think you could do, if I could type. Or whatever, whatever you happen to be passing across, right? So this event alone is what causes the JavaScript to wake up and start downloading, etc., right? And you can see that the code woke up and it printed it back out with all the details. So it's kind of interesting, right, that the mental model you have is just that an event gets sent, and then the right stuff just happens without the developer really thinking about it. And the nice thing about this piece of code here is that it was able to execute it on a server, right? The subscription was on the server. The other interesting bit about it is that there is no need to do cleanup after yourself, because it's just an attribute, right? If this DOM element goes away, right? Where's that DOM element? Right here. If this DOM element goes away, so does the attribute. So if the component disappears, so does its attribute. And then everything just gets cleaned up. So I love this demo because I think you could do proper level personalization, right? Like with this, you can create a personalized site. And this demo is incomplete because one of the things we would like to do is to actually show how if I change a cookie, I will have different header image over here, maybe different shoe, and so on and so forth. And the insight, what makes this easy, is that instead of trying to cache the whole page, which is not possible because it's personalized, you start caching individual subsections of the page. And that is very possible. And what makes it kind of easy from a developer point of view is that it's easy to concatenate things together, right? There's no complicated step that the edge worker has to do to put everything together. It's literally just cut and pasting HTML into the output. And because it's cutting and pasting HTML to the output now is streamable. And we keep talking about out-of-order streaming. So one of the things we would like to do is that when the whole thing is being rendered, let's say the shopping cart takes a long time to render. Wouldn't it be nice if you could just say loading or something in the place of a shopping cart and continue pushing all the rest of the HTML? And then when the rest of the HTML shows up, you can go back and update the shopping cart, right? Out-of-order streaming across edge workers.
How far out do you think that's going to be?
So I think this demo already shows all the key points. The only part that's missing here is the out-of-order streaming. And the out-of-order streaming, I think it's just a question for us whether we want to focus on getting the product out of beta, or we want to focus on the out-of-order streaming. The streaming itself is pretty straightforward. All you have to do is when the edge worker is reading a stream from a separate edge worker, right? Because it's like kind of doing a pass-through. You use comments as kind of instructions for the edge worker. And so let's say this is a shopping cart, that the root edge worker starts talking to the shopping cart, and the shopping cart comes back with a comment that basically says, I have outstanding promises that I don't have yet, so do whatever you feel is necessary. But I am pausing the streaming because I am missing some data. And then the root edge worker sees that comment in the stream and says, aha, okay, so no problem. I can continue passing all the other data across, right? So it's going to continue doing the header, the body, everything else. And at some point, the shopping cart comes back with another comment in the stream that says, I now have the data and I'm ready to stream, and so here is the result of the stream. And then the root edge worker can just find a convenient time in the mainstream where it can insert a script tag with the data that was missing. And when the whole thing is finished, the edge worker closes the connection to the other edge worker, right? So it's not like there's multiple connections going on. It's all done through a single connection and through basically comment nodes that can tell the other side whether the streaming is happening or not. And as long as the framework supports streaming, out-of-order streaming, then the comment nodes basically allow the coordination of multiple edge workers to kind of build up a response. And so I think this is an important demo because I feel like our industry is not doing a good job on personalization. And the thing that's hard about personalization is that the moment you have a piece that is personalizable, we don't know how to render just that piece. We kind of are forced to render the whole page. And the rendering of the whole page is just expensive. So that's one problem. The other problem is that we have hydration. And so even if we somehow modify the response on a server, the hydration is going to come and clobber all over us and return it back to the original state. So any kind of changes really require two things. You have to modify the HTML at the server, and then you have to modify through some mechanism the hydration process on the client. Which is why most people, what they do is they say, you know what, forget it. We're not going to personalize at the server. Instead, we're just going to render a generic thing, and when the hydration happens on a client, it basically calls back to the server and says, like, is this personalized content? Should I personalize it? And then does an update. Or we insert an extra script tag, which then modifies the way hydration happens, etc. And this all stems from the fact that hydration is an afterthought. It's not a fundamental property of how these systems work. But if you can have a system where the server-side rendering is the fundamental property of how the system works, then personalization becomes pretty straightforward. And if you can break the page up into individual containers, then you can start caching individual pieces or putting them out of order, etc. So I'm actually super excited about this demo because I think it allows basically anybody to go and build a proper personalization site without having the resources such as Amazon, right? Like Amazon has sufficient resources to kind of bulldoze through these problems, but most people just cannot. And so can you have a proper, like Amazon level personalization without having Amazon level investment into it? And so this is what we're kind of aiming for. This is the ultimate goal that we want. I think we're about 80% there. So we still have to figure out a few things, but pretty close.
So suppose if this is having the different container, and one container is a React app and another container is an Angular app. Now I need to pass the props, right? So how I will pass, maybe the React is expecting as a props, but the Angular component is expecting somewhere as a property or something. So
yeah, so the inter-container communication right now is just through custom events. And that's a good thing in a sense, because one of the things that it enables is that notice how I showed you that different parts of the system are actually running on separate URLs. That means those separate URLs are owned by separate teams. And means those separate teams can deploy and roll back their things independently of everybody else, right? One of the problems with Webpack federation is that when team A decides like, oh, we messed up, we want to roll back, they can't. The only thing they can do is roll back their code, make a complete new build, and deploy a new build, and hopefully the build didn't mess up, right? Hopefully they had the correct build, right? So you can't do that. Whereas here, the final linking, the final thing that assembles all the pieces together is in the browser, not as a build step, right? It's a browser step. And because it's a browser step, you can have each one of these containers that you see over here to be owned by a different team, that they do their own separate build. They can roll back or push new versions separately, independently, and the only thing that they're agreeing on that they have to be careful about is the name of the custom events and the payload that the custom event handles, right? So they have to make sure that between different versions, the payloads are the same thing. That the structure of it doesn't change.
And suppose one container is dependent on one event, and then suppose the root component is loading, and once it loads, and based on the user interaction, it will pass the object to the next container. So it will wait till that time, or how the behavior?
Yes, so this is all based on events. And if you remember, I kind of pointed out that as soon as the HTML is there that says that you can click on it, it is guaranteed that when you click on it, the event will be processed. You might have to wait until the JavaScript downloads, right? But it's guaranteed that it will be processed. Now, to make sure the JavaScript is there, eager prefetching is through the ServiceWorker is kind of what kind of makes that happen, but it is a guarantee. One of the things we're thinking about is actually incorporating a very simplistic queue into the quick loader, so that you can push things in the queue, and for containers, like let's say there's a container below you, let's say that the header fires an event saying whatever, but the container receiving it is below you, so it hasn't streamed yet. So in that situation, it would be nice if we could just push it in the queue and have a guaranteed delivery that it's sitting in the queue, and then eventually it will be delivered. And that's pretty, that's a pretty straightforward thing to do in the quick loader, but it would really enable other use cases as well.
That would be nice.
Will we get to see a local demo of building a container?
Yeah, I can show you that. It's pretty straightforward. We can do that next.
And so, I mean, we had to do kind of the similar implementation as MFE. So what we did, from the module federation, we just compiled as a component, and then it was React component, and then another application which was built in Angular, they had to consume it. They could not, because they cannot pass directly the props. So we had to wrap in the web component, and then we have to, pass the data as a property of web component. So how it is different from the web component? It doesn't seem like.
Well, web component requires eager hydration, right? Web component requires that some JavaScript runs eagerly and sets up a listener, right? And that alone will probably mean that the whole application is downloaded, right? Because nobody's going to do the trick where you're like, oh yeah, I'm just calling this JavaScript to set up a listener, and then I'm going to lazy load the behavior. Like, in theory, it's possible. In practice, nobody does it, right? So really, what you're saying is that if you want to use a web component, the whole web component, the whole of the code associated with the web component has to be present before you can talk to it. And so one of the things this is solving is, as I pointed out over here again, is that when this code shows up, right, when the application wakes up, there is nothing, no JavaScript, right? So for example, if you don't click on a button to add to the shopping cart, the shopping cart just doesn't get executed, right? And it's only when you want to talk to it by firing an event, only that causes the download of the associated JavaScript, or rather the execution of the associated JavaScript, right? The download might have happened earlier because the ServiceWorker eagerly fetches the code because it thinks it's very likely that you will go and execute it. But the execution of the code is delayed until you're ready to do something useful. Another way to think about it is, if you were to look at code coverage of the code in Qwik, you will be pretty close to 100% all the time, right? Because you're only downloading code that you're planning on executing immediately. And any code that's not being executed right now is probably sitting somewhere behind a $sign somewhere, and so it's not being downloaded.
And one more question, in the container, when there is a source, there will be some kind of a URL. So how it handles the CORS issue? Will not be there any CORS issue, if one component is in different URL and one component in different, so?
Yes, so let's look at it here. So this is our home page. And so in here, we have one container here. You can see it says Q container, and it gets its code from /build. And then in this particular case, this is actually fetching the code from a completely different URL over here, right? So we have to make sure that that server sets the correct CORS headers. right? But that's just a standard thing that browsers do. But by setting the correct course headers, we can do this. Oh yeah, let's talk about prefetching. And also you asked about the containers. So I kind of showed you the micro frontend architecture, the personalization. The streaming we kind of talked about streaming, like we only have kind of in-order streaming so far, but out-of-order streaming or out-of-order rendering is something we're thinking about very heavily. But let's talk about prefetching, because I think a lot of people have a lot of questions, or concerns that you may be in the world where when you interact at something, it's going to be slow to interact, right? Your first interaction is going to be slow. Like, how do I make sure that when I click, I'm not fetching the code lazily? So a good example for that is actually our homepage. Here we are in a dev mode, right? And so when I click on a search box, I'm sorry it's so zoomed out, because otherwise it shows kind of the mobile and then the search box disappears. But let me just clear this. When I click on a search box, notice huge amount of JavaScript shows up, and individually they're not big, but it kind of adds up, and so this is not a good experience. So that's because in development mode, we have two things going against us. First of all, we put every single entry point into a separate file. And the second bit that happens is we don't have the service worker doing the prefetching, right? So the same exact page, when I go to production, same exact thing, go to the network tab. Let me just zoom out so that I can see the search box. When I click the search box, oops. Oh, now let's start with blank. And if I do click, notice only a single file showed up. And that's because in production, we were able to concatenate all the symbols together and tell the build system, like, put everything together. And the way we did that is through vite-config, this file over here. And this file basically says all of the symbols inside of the Algolia search that are listed over here, make sure you put them together into the same symbol. So we kind of collocate them. As of right now, the list is manual, but in the future, we're going to have a service that you can use, you don't have to, that will automatically cluster them and tell you, like, oh, based on how the users use your website, you need to make sure that these symbols are together. And so you're going to have ideal bundle sizes. So you have a question.
So, thing you were talking to me about earlier, which is when you have disable cache enabled.
Yeah, so let me show you that next.
Yeah, but just to make sure that we're on the same page, you were saying that disable cache is a bit of a mislabel because it also disables the service worker.
Yes.
So
in this particular case, looks like few things are executing eagerly, so there seems to be some client code here. And notice right now it all comes back with service worker, right? So these files are essentially instant. If I disable the cache here and I refresh, it still says service worker. What is going on here? Okay, I don't trust this tab of Chrome anymore. Initiator, right? So it prefetches things. What? Yes, it does a service worker, but now it seems like it does not do any difference. Maybe Chrome changed the behavior, but this button right here, when it used to say disable cache, it would say disable cache and disable the service worker. And so a lot of people would try to disable this and then refresh and say, hey, everything is slow because the service worker is not being hit. But it looks like it no longer does this thing. So I'm kind of confused what happened to Chrome. Is that they changed it in the latest version? Not sure what's going on in here. But let me show you the service worker. So when you navigate to this particular page, to make sure that this button of clicking the Algolia search is instant, the system starts prefetching the code immediately, and it does so through the service worker. So if you go to the application, you'll see that the application contains a service worker, and it contains a cache. So if I go to this URL, all of these things, the service worker eagerly prefetched, right? So before any interaction happened on the user side, the service worker immediately started fetching this. So I can delete this cache here, and I can go and delete the service worker as well by unregistering it. And this is now showing me what it looks like when the person navigates to the site without it for the first time, right? So we can try to go refresh, empty cache. And one of the things, actually, let's do this as fetching. Let me refresh this again. So let's go back to application, unregister service worker, take the cache, delete, go to network tab. I can see fetch XHR. When I go and empty cache and hard reload, one of the things I will see, all of them start with Q, don't invert. Why are they not here? Now the service worker is, oh, because it's disabled. I have it disabled again. Let me try this again. Sorry, application, delete, service worker, unregister, okay, network tab. Here we go. So the service worker immediately prefetched these ones, right? Before I even interacted, all these Q files got prefetched by the service worker. And so now when you go to the application, you'll see that the cache got filled in with all of this stuff, right? So before the user even triggered anything or any kind of behavior, the code eagerly started to be downloaded. And the nice thing about breaking that into pieces is that if the user would have clicked before the service worker had a chance to do that, because they're individual files or few number of files, it can change the order in which you download them. Whereas if you have one single chunk, there's nothing you can do. You have to download the whole chunk and be done with it. So the point I'm trying to make here is that disable cache button is kind of dangerous because it doesn't quite do what you think it does. It oftentimes disables the service worker cache as well. And so a lot of people will go and demo Qwik and be like, look how slow this is. And then they click this button thinking they're pretending to be the first time navigation. But what's actually happening under the hood, they're disabling the service worker magic. And so the proper way to do it is to keep this enabled, clear all the caches, and then navigate as the first time. And you'll see that immediately the service worker fills in all the data so that when you're ready to interact with the page, it's there and available. OK, if there's questions, otherwise, yes.
So what I think you just explained, and please feel free to correct, is that we have the normal stage, or the 9 out of 10 case, where I, as the user, probably won't be fast enough to get to a part of the page before I have the shards to run that page. But if I do, there's we already have the case covered where if what I'm asking for will be prioritized.
Yes.
Okay.
So all of these things are basically done. Like, this is, in my opinion, the most efficient way to download code, right? Like, I can't imagine what else we could be doing to kind of improving the situation, right? We remove the code that we know it's not going to be needed on the client. We download the code in the priority order and the probability in which we think you're going to use it. We eagerly download all of the possible interactions that you could possibly do. And we have resumability, which means that we don't have to eagerly execute all the application code. We can just continue where we left off, right? So I can't think of any other trick we can do to kind of improve the situation even further. And again, the lovely part is that this is just how the system works out of the box. There's nothing special that the developer has to do. All right, so one last thing to talk about is React, and specifically, how do you run React code inside of Qwik? So one of the things we have is that React is a huge ecosystem of UI libraries, and so both for the purposes of reusing existing ecosystem and also for the purposes of a migration, we allow you to run Qwik code. Sorry, we allow you to run React code inside of Qwik. And so let's see, this particular demo again starts with no JavaScript. Even the React code doesn't show up over here. But then when you hover over it, the JavaScript showed up. So hovering over the code hydrated the React. So React got downloaded, hydration happened over here, etc., so that we are now ready to work with the slider. And so you can see that this slider is a Material UI slider. This button is a Material UI button. This button, I believe, is a Qwik button, and this table is a table that's lazily loaded. So all of these things, we can kind of show you that we can just use the existing components. So let's look at the code base, how this actually works. Let me see if I have the correct, yep, that's the correct one. Okay, so here's our component, Qwik React demo, right? So that's this one over here. And we have our select, and the select is just a regular select, and it says on value change. We have a callback, right, to go and update a signal in this particular case, I believe. Yep, it's a signal. And then here we have Material UI slider. So do we have, oh, I see, this is the select over here, I see. So this is a regular component, but this slider is a Material UI slider, right? And so the Material UI slider actually has to be imported from a separate file. So we created a separate file called React integrations, and so we have alert, button, and a slider. So let's look at a slider. One of the things we have to do is, the reason why it's in a separate file is because we have to say, like, any JSX that you see here is not Qwik JSX, it's somebody else's JSX, right? So the compilation has to change in here, and this pragma is what tells the system is that the JSX you're about to see is not it's not Qwik one, so don't mess with it. So it's the React one, let the React do its thing. And so in here, you import this Qwikify function, and you pass in a button from Material UI, as you can see over here. And this function then returns an equivalent component that is a Qwik component. So it has all the, so you can be dropped inside of the Qwik application as you would see fit. And we can see that we can, for example, specify that in the case of a slider, we want to hydrate it eagerly on hover. So as soon as, this is what you saw, is that as soon as the user hovered over this, that's why whole JavaScript kind of executed, is because we think you're about to click and execute, so we prefetch all this information for you. Now, the nice thing about it is that we bridge all of the pieces. So let's go to the slider. Notice a slider has onChange, and so we produce for you onChange $, so that now you can lazily initialize it, right? So even though the hovering downloaded and brought the Material UI to life through hydration, once I start sliding it, there's yet another piece of code, which is the callback that gets downloaded and executed, right? So this is normal kind of behavior that you would expect from Qwik. Here is another example, which is now we have a Material UI button, but normally a Material UI button has like this fancy shades behind it, etc. Notice what we've done actually over here. I'm going to see. If I hover over here, no JavaScript is being downloaded whatsoever. So this one is configured to never actually hydrate on the client. But notice I can still click on it. So the reason for that is because we're saying, you know what, on the host element, because we're going to have to put you inside of the kind of the box, on the host element, set up a click listener. So we had the benefit of rendering a button, but we're just not even bothering and hydrating it because we don't think it's worth to have that fancy animation over there. But we still want to be able to listen to the click events on this particular thing. And so we can register a click event without actually hydrating it. So the component, the button got rendered on the server with its styles and all the important parts, but on the client, we're not paying for any of it. This shows, yes?
Question. So let's say someone does want those fancy pants animations, and
yeah,
what we colloquially refer to as the bloop animation.
Bloop, okay.
Is there a way to?
Yeah, so it's as simple as basically telling us when do you want to hydrate it.
Okay,
right?
so you effectively opt into how you want.
See, now you have the fancy animation. See that? the bloop or whatever you call it.
Yep, there's the
It's
bloop.
there. It's there. So I'm just kind of showing you different possibilities that you have here, right? The other thing we have working properly is that, notice this one. There we have a material UI alert, and inside of it is a quick counter, right? So this is an alert that is owned by material UI, and inside of it, through its children, we project a container. So this quick counter is a quick piece of code, but the outside of it is a material UI piece of code that runs inside of React as well, right? There's a 3JS here. How do I click on something? How do I get it running?
Pardon me, but before you move on there, I wanted to understand the boundary of the reactivity. I imagine that when you're incrementing that number, that nested quick counter, no, below that, this is a warning from Qwik. I could have sworn that you were projecting a quick element inside of a movie container. So I guess what I wanted to understand is every time you're doing that, you're incrementing something that's then triggering an event, passing it up to the document, and then this is the thing that crosses over the boundaries. And then that MUI container receives it as a prop, and it triggers a redraw.
No, I don't think so. I think the way it's set up is that this follows the Qwik rules, not the React rules, right? So the Qwik container is rendering itself independently of a MUI alert. MUI alert doesn't even get awoken. Like, it has no clue what's happening in there. It's not part of the render tree at all.
Interesting. So if you Qwikify enough things, then you get rid of that re-rendering.
Yes.
The unnecessary re-rendering.
That's right. So if you think about this, with Qwik React, you kind of have Astro, a better version of Astro for free. Like, if you want to lazy hydrate components, islands, whatever, sure, do it. And it turns out it's even more fine-grained than what Astro allows, and we properly pass the state around, which is what Astro doesn't do.
So what's the drawback?
They've been around longer, so they have more of a mind share, right? When I talk about drawbacks, I think there are two kinds of drawbacks. There is the intrinsic and extrinsic, right? So extrinsic drawback to Qwik right now is it's new and there's no ecosystem and there is no mind share, right? But time will solve that particular part. An intrinsic what's the word I'm looking for? Intrinsic downside of Qwik are things that will never improve, right? Or will forever be this particular way. And that's a much more complicated discussion because you have to learn new rules. Like the $ has rules, right? We talked about them. Like, you have to learn those rules. You have to kind of think about the fact that the main thing about the $ is that it's asynchronous and that it forces serialization. So you can't just randomly serialize something and assume that magic will happen. So there's a new set of rules, and those rules are unlikely to ever change, right? So those will be kind of the intrinsic drawbacks to the system. But I'm going to argue that those are actually very minimal compared to the benefits that you get, right? So as of right now, most of the kind of drawbacks of Qwik are extrinsic to the fact that we are new. The documentation might be not as good. The number of videos is not as good. The community is not there. The third-party system is not there. But that will be solved in time. Whereas, the intrinsic things of, for example, React is making a clock example is complicated because of the way the thing works, and it's just not going to change because it's just the fundamental property of React, right? And so the $ have a meaning in Qwik, and that's not going to change because it's a fundamental property of the system. Sorry, I probably went on a diatribe over there. Yes?
With the $, that is also a convention, right? Like observables uses the $ convention for streams and things.
Well,
but it's not required in those cases. Here it's required.
It's required, yes.
Okay.
So the $ has a meaning to the optimizer. So the optimizer is a piece of code that extracts this. So actually, a good place to go is we got to go quick. Can I get a proper zoom? Okay, tutorial. What happened to the playground? It's not there anymore. What? Oh, I see, that's not opening playground. All right, so we have a hello world. Let's open in playground, and I'm gonna up the font size. How's that? So right now, there's no dollars. Well, there's only one $, right? So you can look at the symbols that are exported and kind of see that currently there is basically just this content right here that's exported, right? Once I add a onClick, right? The optimizer doesn't know that onClick is special or anything like that. Purely the only thing it cares about is that it's a symbol ending in a $. That's all it cares about, right? And so here, if I add onClick, that alone is going to make now a separate entry point for us, right? So the optimizer is really in the business of purely just, I see a $, I extract it over. That's all it cares about, nothing else, right? So there isn't like some complicated set of rules or special things, etc. The reason why this is important is because now as a developer, you want to create your own use method that ends in a $, you can, right? Because we don't have a special set to us. It's a method call, ends with a $. If that's the case, take the first argument and yank it out and do this magic for it.
Does that imply that the line you just added on 4 would be included within the scope of the component $ symbol? So would onClick close over?
Right. So let's look at it. So the app component got hoisted out. It's a top level thing, right? This is the closure here. And notice that it says that, wait, what? There's my P. What happened to onClick? Let me refresh this. There we go. So here's our onClick. And it basically knows that whenever you see a $ on it, take the first argument and do this to it. Move that function somewhere else. Actually, it doesn't even care if it's a function, right? It just says, take that argument, whatever that is, move it to a separate file, and then leave behind a dynamic import. And then tell me what symbol did you put it as, right? In the dev mode, we also put additional information about things in here, but that's just the dev mode. In production, that's not there.
But you're effectively inlining a reference here instead of you're leaving a reference instead of closing over the function.
That's right. Okay. And so when these things got moved, if you look at the bundle, so in this particular case, we don't close over anything, right? And because we don't close over anything, even the framework doesn't get included. So let me close over something. Let's say we want to say, okay. So now that I closed over it, and I have to refresh it? Yes. See, now it inserted the lexical scope. Right? And because I had to insert the lexical scope, now it caused an import from the framework. So this thing here is the framework itself. And oh, by the way, none of this stuff is stuff we do. We just rely on rollup, right? So this is normal rollup stuff, right? Like we're not trying to reinvent the world. Our only job is to produce extra files that we can then feed to the rollup, and the rollup does its magic. The only other item that I can give you a very quick overview is Builder. So let me actually zoom in this a little further out. Doesn't zoom out more? Okay. Let me disable JavaScript on it and refresh this page. So when you come to our page, Turns out half of the page is missing. It's not here. See, it just says loading. Let me zoom in here. It says loading, right? And we do that because if I enable JavaScript, because there is more stuff that's below the fold, but like, here, refresh this. There's more stuff below the fold, but we don't want to, ship it, etc., until you start scrolling, because until you're going to get to the bottom, like, why send it? And one of the important reasons why we don't want to do that is because there is, where are they? There are Twitter testimonials. Is this it? Yes, here we go. Here's the Twitter testimonials. And I don't know if you looked at it, but the Twitter testimonials download like megabytes worth of JavaScript, and they take forever to bootstrap, right? So we have a homepage where we're touting how important it is to have a fast startup. It would kind of suck if our own homepage was slow because we happen to have Twitter testimonials in there, right? So the way we solve this particular problem is we just put them below the fold, and we tell the system, like, don't bother downloading it. And the way this actually happens is when you first navigate to a page. Let me go here. When we first navigate to a page, query selector, we have two containers, right? The container that comes from the site itself and the container that comes from Builder. When you scroll, more containers show up. Oops. So now if I run the query, now we actually have 3 containers. Like, additional container showed up. The bottom part of the page is actually yet another container that just lazy loads and shows up when you scroll. And because it's literally just inner HTML into that location, there's nothing really to do. Like, the code for it is beautifully simple. If you go network, I think if I search for lazy, there we go. The code for it literally just says, remove the on-window scroll event, reset the style height, and inner HTML the content into it. It's really that simple, nothing else. And that's it. And it works as you would expect because you're just concatenating stuff into the HTML. So this site here is a site owned by by us inside of the repo that you see, but this content over here is not. It turns out if you go to builder.io, come on, load. The middle part of it is handled by our CMS system. So if this loads, no, what's going on here? Okay, the middle part, is held by the. Let me just get this URL fixed here. Render equals SDK. Okay, so notice now our marketing department can go and change anything that's not in the header. Right? The header they can't touch because that's rendered by the application itself, but the center of it they can. So all of this stuff is editable by them, and of course the footer also they cannot touch because that's rendered by the open source repo, so to speak, right? But everything in the middle is completely editable. So anything I do here, like for example, we previously added too many question marks, exclamation points rather, I can just publish, and within a couple of minutes, this UI will update. So what's going to happen is that at some point the caches will expire in the CDN. I mean, they probably set on something like 1 or 2 minutes. So normally when you come to our page, you're hitting a CDN cache, but then the cache expires like in 2 minutes, and then every 2 minutes, basically, it's a full SSR of the page. And so in about 2 minutes from now, when the people will come and navigate, it will now start showing it without the exclamation points. Right? And the cool thing is you could do behaviors too. So you can click on it, it says copy to clipboard, whatever. So this is super easy because we can just hand it to the marketing people and say like, hey, make ours a nice web page. And they just go and edit anything they want, and they're not kind of constrained by what they can do. We can also add components, etc. And so that's kind of what kind of falls into it. So that was pretty much most of it. I'm kind of out of ideas of what else I can share with you. So unless you have questions, yes, questions.
So you had mentioned some way of aggregating user statistics.
Yes.
And we don't need to give it the full demo, but I am curious as to how that works.
Yeah, so it works. As I said, everything in here is based on events, right? So what happens is you can set up an event in document, add event listener, and you can use symbol. If I remember correctly, that's going to give us an event, and we can do console log, and then we can say event.detail.symbol. Okay, so if you do that, then you see the symbol showed up? If I click on stuff, a whole bunch of symbol shows up. So as I interact with the page, basically symbols are showing up, right? Because every time the framework says, I need something, it does it by firing this event. It fires other events, but basically everything works through the event system. And so it's very easy for you to observe what is going on. And the idea is you take this information, you collect it, you run through some clustering algorithm, look at the timestamps or whatever, right? So actually, let me refresh this page. A more appropriate system, I think, would be to not only print symbol, but also do e.timestamp, I think.
You have a misspelling on timestamp.
That's stamp. Okay, let's try this. No, is it not timestamp? It's not timestamp. There is an event somewhere on the details. I don't remember what it is that gives you the timestamp, right? So between the timestamp and the symbol, you can create clustering information. You can basically figure out like what are the users clicking on more likely and what things are what's come together, and then you can feed that information into the build system. And so when the optimizer creates these extra files so that the rollup can do its magic, it can create the files in such a way that the rollup will automatically put things together. The other thing that maybe wasn't clear is normal frameworks have no idea about what's happening on the build side. Like they're completely clueless. In Qwik, build information is fundamental part of the information of the framework. The framework needs to know where are the symbols, where do we download it from, what are the relationship between them. All of that information is a runtime information that's available to the framework. So when we create a build for you, the last step of the build is something we call the manifest. The manifest contains the full graph of all the symbols, the relationship to other symbols, which symbol imports which other symbols, which file they're located in, basically everything you could possibly want to know, how big these files are, where they are, everything you possibly want to know. And that information is available to the framework at runtime. And so framework can use that information to do all kinds of optimizations, right? And that's kind of unique because usually that's not how systems work. So you can just basically collect this, and then you can go and use that information to feed the system. The other thing you can do, and I can't remember off the top of my head, so give me a second. There is a script tag that sets up, here we go, QPrefetch. So, no, that's not QPrefetch. No. Module, here we go. No, it is QPrefetch. You can fire a custom event with a set of bundles you want to prefetch, right? This line here, this piece of code here that's auto-generated is when the framework ran on a server, it collected all of the listeners and said, when I rendered the SSR on a server, I saw all these possible listeners, and those are the possible entry points for the system. And so it includes them in here and says, ServiceWorker, make sure you have these because these are things that the user can click on. But you can augment this and you can add more things into this list. So if you augmented this list and just gave the whole thing to the ServiceWorker, then your app essentially becomes offline immediately. right? Because you already have a service worker that prefetches and gets it, etc. The Q dash whatever hash, that is fetched, that is cacheable forever. Like that hash is a hash of the content of the file. If the content of the file stays the same, that hash is good for the future, right? So if a person comes and navigates your site and only part of the application has changed, then only some of the hashes will change in this list. The ones they haven't, they can just reuse, so they'll have an improvement. So again, this is a benefit because today when you show up to a site and you have a new version, you usually invalidate everything because your chunks are humongous, right? And the other thing to understand is that the symbols are stable between the builds. So while the hashes of the Q files are not, the symbols are stable. And that allows you to use knowledge of previous build to augment the next build.
So, I mean, you just showed like how the symbols are listing up in the console. So when you said like we can collect this, is there any framework provided?
Right. So we're going to
backend?
provide a framework for you. And it's going to be a service we're going to provide for free so that your application, you can just give it, set it up to send the data to us and we will give you the answer for free. But if for whatever reason you don't want to give us the data or whatever, right, you're welcome to do it yourself. There's nothing proprietary in here. I'm just kind of showed you that every time a symbol is needed, the custom event is fired, you just have to collect those events and then send them to your own system and do whatever you want, right? Out of the box, the bundling system, I think, has 4 different ways of bundling, like, put everything in the same file, put everything in the separate file, put everything by component, and those are kind of the default heuristics that we have. But then the idea is that as you collect behavioral data, then you can really fine-tune this information. And again, I want to stress that this becomes a configuration information, right? You don't have to change anything about your application, the way you've written it, etc. Like nothing changes. It's just some person who wants to optimize the heck out of the application, right? Twiddles some bits, and the rest of the engineers don't care.
No, go ahead.
All right. So yeah, kind of on the topic of like engineers don't have to worry about it. One of the things that we talked, or we kind of glossed over quite a bit yesterday, and I'm really curious about is developer conventions. And when we were looking at how Qwik City does routing and determines which layout to use, there's a whole lot of conventions that are defined.
Mm-hmm.
Are those configurable? Are they, conventions are something that a lot of developers develop a lot of strong opinions about. And if they disagree with, I don't want to call it routes, I want to call it areas or something.
Yeah. I don't think as of right now that's configurable, no.
Yeah.
I think all of this is kind of hardwired in. Are they configurable in like Next.js and stuff and SvelteKit?
No,
I don't think they are either.
I don't believe so.
Yeah, there's huge amount of things.
I know that was one of the major attractions when React was new is it was unopinionated, and at the time the community pendulum had kind of swung away from overly opinionated and just let me define my own routing mechanism and you worry about the rendering of my thing. So finding a balance between overly opinionated and under opinionated is always a challenge. I was curious kind of how Qwik finds itself striking that balance.
It is, it's pretty opinionated, I think. Well, in the case of routing, it's as opinionated as Next.js or Nuxt or SvelteKit or any of those ones, right? In terms of the actual Qwik itself, the framework minus the meta framework, I think it's about the same as React. Like you have the methods and we don't have statements for you like what you should or should not do.
So reacting to that though, you were talking about opinionated versus unopinionated. When it comes to routing, I'm thinking through what are the drawbacks of a file system based router, and that it manifests as a problem when you're limited to data fetching on a route by route basis. that goes away when you have the ability to do tree shaking of your data and have that granularity with the signals. And if I'm not mistaken, I think the thing that makes you want to back away from a strong opinion there is that you can't have your cake and eat it too, you know. But I think this decouples the advantages and disadvantages. Like I'm still trying to figure out what are the disadvantages aside from not enough people know about it.
Yeah.
I think that's the main one. You have to learn new things. You have to reprogram your brain to think about it in a different way, right? That's definitely falls on the category of extrinsic the disadvantages. But like, as far as what you can build with the framework, it should be the same as what you can build with Angular, Qwik, or any one of the other ones.
Yeah, but like we were also talking about, the other aspect of it is, you know, for enterprises that are used to being able to just serve up static files and have everything rendered client side, there is, you know, at least for some enterprises, there's going to be a change in how, you know, where does the build occur? You know, what's doing the serving, and where does that live?
So you can have SSG, right? What is it? Static site generation, right? You can have a SSG system. Now, in most SSG systems will not be an application because it doesn't make any sense. But in case of a Qwik, why can't it be? Like, yes, that's the initial state that you SSG'd on during your build. But like from that point on, you can do whatever you want. It's totally interactive. You can fetch data, you can manipulate data, you can use client effect to kick off operations, etc. So all of that just works.
But at that point, you're getting an initial page load that's faster because it's SSG.
Yes.
And you're reducing the amount of JavaScript footprint. But
Correct.
then from that point onward, you have enabled essentially client side.
That's right. For that point onward, you're essentially an SPA. Right. And you can do that, right? So Qwik really blurs the line of what is a server, what is a client, what is an SPA, what is an MPA, what is a, you know, all of these lines are just really blurred, and it just becomes like, well, it's kind of all together at once. And at first it might look scary, but I think what it enables is amazing. Mark.
I had a question from online. Unscrolling, can the lazy behavior be customized to be more like greedy or like prefetching, like rather than when it fully comes into view, prior to it fully coming into view?
Yeah, so those are all separate things, right? So when the prefetcher loads your data, that's controlled by the ServiceWorker. That controls basically when the JavaScript downloads. That's independent from when you actually start executing the JavaScript. So you can, for example, say, I want to start prefetching the moment you scroll, or you can say, you know, I just want to prefetch immediately at the very, very beginning. And then the separate question you can have is like, well, when do I insert the HTML? Do you want to insert when it becomes visible, in which case you're running the risk of slightly seeing loading ... Or you just want to immediately insert at the moment scrolling happens, which means it's way more eager than it has to be, but it probably, you'll never see loading ...
Setting a threshold of like 200 pixels or something.
Yeah, so those are all like things that you as a developer, it's now in your hands to choose, right? Before, it was not in your hands to choose. Like, you just couldn't do this. Like, there was no easy way to get this behavior. And now you have a relatively easy way of customizing whatever you want.
So in case of the MFE, suppose in big enterprise, maybe we cannot influence, like main website will become a quick application in one day. So if we start from, say, like the smaller MFE in the Qwik, and that is getting consumed in the React or Angular app, how it is possible, like how it will consume the events in the quick way?
It should all just work because as I said, like, as long as you can tell your framework not to mess with that DOM, right? Don't destroy it. As long as you can do that, then into that inert DOM you just load Qwik. It's just as simple as string concatenation, right? That .inner HTML, you just load it in there, and as long as the Qwik loader the script tag is somewhere on the page, it just continues running. That's the kind of the beauty of resumability. It doesn't differentiate whether it's loaded into something or not, or how the HTML got there. All it knows is that if you click here, go update that thing over there, right?
But then how they will include that MFE code in their, say like, say React or Angular, they don't support the container or all these
right,
things.
So they might, so the way I would do it, for example, in React is that I would use dangerously set inner HTML or something like that, right? I would just grab the HTML. I would have a separate Qwik server that renders, SSR renders the application or the content, right? And then I would grab that HTML content and I would just dangerously set it inside of the React and tell React, like, do not descend into this DOM tree. This is not yours, right? And as long as you can do that, then it just works.
And how it will receive the data from React, because it is like custom-based event, attribute-based event, right?
Oh, right. So how do you do communication?
Yeah.
We are exploring the possibility of doing kind of the reverse of Qwikify, so that you can take a Qwik code and do it in React. Like, it should be relatively straightforward. But for now, you could just use the event system, right? Just fire custom events to kind of get it going.
All of the components are living inside the window, and
Yes.
you can use that as the universal communication space. Is that right?
Yes.
But that would require, for this kind of scenario, we'd have to provide our own events and event handlers. Is that
Yes.
right?
Yes.
Okay. Yeah, but that's still way more convenient than another scenario I could imagine, trying to glue two frameworks together.
Yeah.
So we were looking for documentation to demonstrate how to use multiple frameworks in an MFE type environment. Has that evolved since?
Yeah, that documentation is something I need to put together. So that's homework for me, actually. Yeah.
I think a lot of concerns will be allayed if we have a chance to take a look at
There
that.
is some discussion of it in containers, concepts. No. I mean, advanced. Oh, it's going to be advanced. Containers right here. So yeah, some of it is kind of explained on a high level here. Oh, look at that. It's in this section on micro frontend, but it probably has to be flushed out more. There's also this button that says edit this page.
So, and I guess the one other concern that I had is you were showing how each of those separate routes, those micro front end containers could be rendered individually. In different environments, I could see how for security reasons you want to make sure that that route cannot be accessed directly. It can only be accessed from the host app that's weaving all of these pieces together. And do you have a method of protecting against that?
So we showed you the login page yesterday, right, where we said like make sure the cookie is set or something, otherwise redirect to a different URL. Like there was a request handler at the top level. Other than that, I think that's on to you. Like, how do you make sure that you don't serve up the content into the wrong hands, right? I think one thing I can show you regarding the containers is that if you go to the root, there is a file called root.tsx, right? So that lays out your HTML, but even before that is entry SSR. And so this basically says render to stream the root component, right, which is basically the whole HTML, and gives you the prefetching strategies, how to get code, etc. All kinds of options are passed in here. And by the way, here's the manifest, right? This is the information about all the pieces that the framework needs. Anyways, in here, this defaults to the HTML tag output, but in here you can pass I forget off the top of my head where it is, but in here, one of the options, streaming, stream writer, somewhere in here, there is an option you can pass that basically says, don't do it into HTML, do it into a div tag, for example. And now what you get back is just a div tag that you can insert into anywhere you want. Mark?
A question from online. could you talk to resumability in a situation where there's many people working on the same document, like in the case of a collaborative text editor?
I mean, at the end of the day, it's just events, right? Like the events are either coming from the user that's sitting in front of the computer, or they're being fired through some kind of a stream, right? That the server opened up to the client. And so this should work just straightforward. Like I think streaming, there's a streaming API, right? I believe in the browser, and it just will fire events for you. And so you just have to listen to these events, and this event listening will automatically set up lazy loading and all the other stuff that we've seen, right? Again, it all comes down to that the whole machinery is all based on events. And as long as it's just events, it just works, right? Whether the events are coming from a separate worker thread, or they're coming out of a stream, or they're events that are coming out of user interactions, like the system doesn't care. It's just an event that's bubbling up through the DOM, like all other events do. Should we call it a day? All right. Well, you guys have been awesome. Thank you so much for listening to my crazy ideas, etc. And I also want to send a shout out to Adam Bradley and Manu, two guys who are doing most of the code behind here, and they just did an amazing job. Manu is the guy behind Qwik. Adam is the guy behind Qwik City. And so all the amazing stuff you've seen mostly goes to them. I'm just a guy with the crazy ideas, that's all. Thank you.